Okay, so last time we created that DB client class, and then we started to implement a little bit of logic into it so that we could use it in our game class. At this point, our application architecture looks something like this, right? So I like to kind of always just like go over it again and again so that we actually have some solid understanding of what's going on. So we make LLM requests from our study buddy, right, with our LLM client to Olama in this case, and that's our LLM. And that's just to verify things, right? So this flow here, that's just to validate an answer. Okay. Now we also have a deck, and then we also have many cards associated with that deck. Okay. And that's also integrated in. Game is also part of the entire system where it has one deck so far. And the game also connects to the LLM client. What we just did last time was create that DB client class, DBC, and now a game also has one of these guys here. This DB client then actually connects to a SQLite database, which is basically a flat file. Okay. So then when we issue any request to DB client right here, this is on behalf of game. DB client is actually issuing queries to the SQLite, and then out comes back the data back to the game, and we were able to print that. We also we also know that every time we do like the following, if we were to select data, we get back an iterator, okay, and that allows us to actually do a for in loop on a row of whatever this select returned back, because a select what's that?
I have a question. So when we do a select, an iterator object is returned. Like, is this like a general idea from all databases, or is it only from SQLite that we get back this iterator object?
Great question. So in most database libraries, this is actually a general pattern.
Okay, got it.
Would you like to know why that is the case?
Sure.
Yeah, no, you should.
Yeah.
The reason why we use an iterator is because databases, if you imagine a database table, right? This can be ID 1, this can be ID 100,000. Okay? What that means is that you really don't want, when you do a select query, you could potentially return back 100,000 rows. That's a lot of data, right? So let's say you have I don't know some text here as a column, and let's say you have more text, and then you also have like a number. Okay. Suppose now you have each in one row, you have text one that is averaging around maybe 300 bytes, or let's say in Unicode that'd be like 150 characters. Okay. Text 2, on the other hand, averages maybe, let's just say a little bit more conservative, 100 bytes. And that is giving us maybe 50 characters. Okay. You know I'm getting these numbers, right? 2 bytes equals 1 character, because we're on Unicode. Now, the number in this case is going to be stored as maybe 8 bytes. We know that. 64 bits. So, yeah, one number. And that's 64 bits. Okay, so that's like one single row, right? Now, what is the total of this? This is actually 408 bytes. Okay? Doing the math now, what that means is that if we have 100,000 rows, for example, we got to multiply that by 408 times. So what would that give us? Was it 4 million? something like this, 4,080,000, right?
Mm-hmm.
Okay, bytes. And that turns out to be a 4.08 megabyte payload just for selecting a big database like that. And perhaps more with metadata or something. So you see how like you could potentially run into a situation where if you don't have an iterator where you want to get, you could potentially like, let's say in a world without an iterator, right? When you select that table with 100,000 rows, those 100,000 rows come back at you all at once through the network.
Wait, actually, is that, can you go back? 108 times 100,000 is 40
For
million.
40 million and 800,000
Yeah.
then.
Okay,
Okay.
sorry, I didn't. Yeah.
Yeah, it's
Okay.
okay. But
Yep.
what I'm trying to say is, and that is actually even worse, right? That is
Mhm.
40.8 megabytes.
Mhm.
Okay. If you didn't have an iterator, you would return all 100,000 rows where each row is 400 bytes each. That leads to 40.8 megabytes being returned by the database over the network,
Mhm.
right? That's with no iterator. But what an iterator does is that it returns you back a subset of the data at once, right? So it could be every 10 rows. And then when it reaches maybe like a window, it starts to fetch the next 10 rows. Starts to fetch the next 10 rows. And then in that case with an iterator, you don't actually get all the data back. You just get what you need in that window first.
Mhm.
If that makes sense.
So we have like a huge collection, and with the iterator, we're getting a chunk of it each time.
We're chunking it up.
Okay.
And that's what some database engines do. That's the reason why we use iterators. Like even though let's say you only are interested in like 2 or 3 rows at a time, it doesn't mean that you're the only one who does that, right? There's in like at scale in big companies, you might be selecting millions of rows at once. And you don't want to select the whole 1 million at a time. You only want to get what you need and process it each time in that case. So you want to stream that. And that's where an iterator could be useful for, where each iteration just makes another like fetch internally to the database. Does that help?
Yeah, that helps.
Yeah. So that's why we use an iterator, because you see this is only 100,000 rows, right? And this is for 8 bytes. But obviously that was a column that was a row with only 3 columns in this case. So think about the real world, right? This could be really bad. So yeah. So that's it today, and then let's actually do something. Let's actually start building up our game class even further. So if we go back here into our game class before, if we were to go to this testdb stuff, we actually wrote most of our test code here, right? Okay, but there's one thing here is that it's not really well integrated with our code base. We want to actually be able to, first of all, do the following things. Given the deck, or given, let's see, we want to select all cards given some deck. Okay, that's like the first thing. Okay, for each card selected or from given some deck from database. Okay, given each card retrieved from the database, I want to create a card object. In this case, an instance of card. Okay, you want to loop through, right? Card, basically the row. Okay. Add each of those of those cards, card instances, into the deck. Okay? So it's really the same thing as when you were reading in the JSON and going through each JSON object and then creating the card instance. But now what we're going to do is we're going to select all the cards from the database and then looping through the iterator to create the card objects and then adding each of those cards into the deck.
Mm-hmm.
Okay, so now if we were to go back to this architecture here, it's starting to become clear that we're missing one more class, and that was the data loader. Where previously it had actually took data from JSON, okay, and then basically loaded the stuff into the game, essentially. Now what we want to do is we actually want to use data loader and interface it with the DB client. And instead of loading JSON, we'll just load whatever's in the database here into a deck and put it into game. Data loader will actually manage all of that.
Okay.
Okay. So looking at that, let's forget about this for now. Let's remove the test DB stuff. Okay. And let's actually now open up our data loader. Now, looking at data loader, you see how we have a load deck here with a file name?
Mm-hmm.
How about now, let's make data loader do what game did and have a DB client being passed in when it's instantiated. And let's actually give it an instance variable just like we did with game called DB client, like this, self.db client. Okay. Now, when we say load deck, the file name here is no longer the file name, but the DB file path. Okay.
Okay. Yep.
So in this case, it'll be studybuddy.db. What we can do now is we can just connect with our DB client. Connect. Or actually, oh, it's already connected, right? So we can start this with none. Okay. And let's actually not have anything. And let's actually then from DB client import DB client like that. And let's actually have, given this DB file path, let's create a new DB client instance like this with a DB file path, like that. Okay. Now, at the very end, before we forget, let's actually make sure that we have some sort of code that will close the connection.
Okay.
Okay. Now, next, the first thing we want to do is actually select all cards from the database, which is going to be using DB client .query. Okay. So let's just make it simple now. Let's not care about the deck for now. Let's just select our cards blindly. So we can do self DB client .query, and we have a statement and we have params. So let's do select star from card. Okay, and we don't need any params. We'll just select every single card. Okay. At this point, we're going to get back some sort of iterator. So let's just call this result iterator, like this. And then we can just then loop through. So loop through the result iterator, fetching each row, and get the description, label. Let's see, get the description, label, and category to create a new card instance. Let's call it that. So same thing as before, for row in result iterator. So this is going to be whatever's in the card row. Okay. Let's just get the category. So, label. It's going to be row. Label like this. Or what is it? How do we do this? Oh, it's a tuple, right? So it's going to be 0. And then next is going to be description. Okay. And then next is going to be the category, row 2. Now, how do we actually know what indexes these things are? Like, how do we know that row 0 is label, row 1 is description, and row 2 is category? We don't. So that's the reason why it's best not to use star and instead define it correctly, saying label, description, category, and then the select query will actually return row objects in this order right here with these columns in order. So that's how we do it. Does that make sense?
Yeah, that makes sense.
Yeah, so now we want to create new card objects. Okay, so we say cur card is now going to be card. Okay, and that takes in label, description, category, just like that. Okay. And before we do all this, we should probably create a deck object, just like we did in the JSON version. Okay. And then what did we do here in this code? Deck.add. Okay. So we do deck.add per card like that. And then we can do deck.shuffle when we're done. So outside of the loop, once we're done adding everything, we can do deck.shuffle like so. Like, okay. Then we don't need any of this anymore. This is like all file system stuff. So once we're done with shuffling, we're closing the connection. And let's just return our deck, just like how we did it before. Make sense?
Yep.
Okay. So let's review what we did here. So data loader just defines a new DB client with none is to initialize. So our API for constructing a data loader doesn't change. And then we have API here called load deck, where now we changed it from a file name to a DB file path. So that's going to be the StudyBuddy StudyBuddy.db. Then we create a new DB client with this given file path. And our API internally, we go here to DB client, already makes the connection here with SQLite 3. Okay. So given this file path, we already create that connection. So that's fine. And then we use our DB client's query right here to select label, description, category from card. That gives us back a result iterator. We create an empty deck here, and then we go through each row in the iterator, extract the label, description, and the category from the row tuple, the current row, to create a new card instance with label, description, category. Then we'll add this card instance into our deck, which is, basically a list internally, and then we'll shuffle everything. After that, before we actually return from our function, because we only call load deck once, we just want to close the connection, and then we can return our deck object. Okay, so now where do we actually use data loader? We use data loader in our main.py, I believe. Right here. You see this?
Yep.
Okay, so instead of data.json now, let's actually do StudyBuddy.db, like that. Okay, now let's fix our game. Our game does take in the deck, but then internally our game has a bunch of instance variables that we don't want right now. It's like trash. So So we were to go to our game.py. Looking at this, you see how we have self-DB client here? We don't need that anymore because we're loading it from data loader now. So I'm going to delete this. I'm also going to delete, oops, not that, this one. Okay. And I'm going to check every other occurrence. Okay. I don't have any more here. So we're clean here. So now let's go back to main.py. Everything else looks pretty good now. So it's our data loader that's the real thing that's supposed to select stuff from the database. And behind the scenes, all it's going to do is just build out a deck by selecting everything from the database. And then once the deck comes back, well, nothing changes here. You're just going to pass in that deck to the game. And then the game will actually play with that deck like it was before.
Okay.
Okay. So let's just test it out. See if we broke anything. We should be getting the equivalent behavior at this point. So let's do that. Making connection, closing connection. Uh-oh. That doesn't look right. Oh, I know why. Okay, first of all, we have too much logging. So we, where are we at? We had a making a connection, closing connection. Let's see. Making a connection. Oh, right here. Okay, so we have that. The reason why we're getting nothing is because we had nothing in our card table. Right, we had nothing in our card table. So let's actually insert stuff into our card table. Okay, so in the real world, how this usually works. So if we were to, let's just say, quit out of this, okay? In the real world, let me clear this. We have scripts called like migrations, for example. Okay. And migrations are basically SQL scripts that kind of just sort of take a base database, like an empty database, and then pre-fill it with data so that when you deploy, you have stuff that's already seeded in. So migrations can be something like creating tables, adding new columns, changing data types of the columns, or like inserting initial data to a specific table. Those are separate scripts. And then like maybe down the line when you and your team decides to say, hey, let's actually add a column to a table. You would then create a new script called a migration script that would just basically have the specific SQL statement to actually add the column into the table. And then like you deploy to production, you just run this one script and then boom, you've migrated your database. Okay, so let's write our first script to actually seed our data into our database. Okay. So for that, let's actually make a new folder. Let's call it migrations. And then let's go in. Let's use Vim again, and let's actually go into migrations and create a new file. Let me see if I know how to create a file here. Is it just migrations? Let's call it seed.py or seedcards.py. Okay, yeah. So what do we need here? Well, we need access to the database, right? So again, this is where we can leverage our DB client. This is a different app. This is a different place where we can actually leverage our DB client. So the first thing we want to do is import from DB. How do we do this? From DB client, import DB client like that, right? I don't know how to make like modules, so I'm not sure if this will work. Like I don't know how to like do those imports where it's one directory up. So hopefully this works.
Would it be // something?
Like .. right?
Yeah.
Yeah. I'm not too, we'll look it up later.
Okay.
Yeah, we'll look at it later. Okay, so, but basically what you want to do is you want to, first of all, we want to open our JSON file, right? Our JSON file right now has all our cards, correct? So we can do that, or we can just type it manually here. For now, I think we just open our JSON file to get each entry and then just do insert statements into the database programmatically. What I mean by that is I can just do this with open what's it called? Data. Shoot, what was it called? Data.json. Okay, data.json with open data.json as f. Okay.
Yeah.
We want to also turn that into an array of dictionaries. So we need JSON, import JSON. Okay. So we'll have this as text data is going to be f.read. Was it read? Just read, I think. Read all? Read. Okay. And then let's actually then turn that into a JSON object. So JSON array is going to be JSON.loads. Convert that text, so text data, into JSON array. Then we want to iterate through, right, for item in JSON array like that. So that's a dictionary. So basically, it's something like label is going to be item label. I think that's what we called it. And then description is going to be item description. And then we have category is going to be item category. Okay, and now let's just like print that out for now, just to do some sanity check as an F string. So loading label, description, and then category. Okay. And just so you know, right now we're reading stuff from data.json into basically a data structure so that we can use this information to dynamically build insert statements to seed some cards into our database. Okay, so because we need some data, right? Yeah. So in that case, let's do Python migrations. Was it seed cards.py? Okay, so yeah, invalid syntax. I think it should just know automatically. Let's see. See. No module name DB client. Let's see. Touch. Is it like this? Init.py. What was that? That file that Python import module parent directory. Let's see. Importing modules from parent folder. What is it called? Init.py in each folder. Okay. So I think what we need to do is we just need to do like init.py right there in the root directory. Okay. So we have an init.py here. And I think for migrations, we also need init.py. And then maybe that works. So Python seed cards.py. Huh. Do we know how to? You could use relative imports. ... That looks wrong. Let's see. I have a feeling like I can't remember, but I've run into this quite often before. From PT. I have run into this a lot. From ... import that. Okay. So if we go back here, like this. Attempted relative import with no known parent package. Why is that? like that. Is there a folder? No. Oops. Yeah, that doesn't work. Okay. Then you know what we should do? Just to get around this for now. CP migrations seed cards.py to this directory.
Mm.
just
just
seed
get around it this
Yeah.
time.
Yeah.
Okay.
Let's see, migrations. So let's remove this one.
Mhm.
Okay. Now let's go back and test it. We don't have that anymore. Python seed cards.py. Okay, good. At least we're not blocked. It's just let's figure it out. This is the reason why I'm learning Python too. So, okay, so we actually are able to load up all our cards now, right? So here's the label, and here's the description, and then here's the category. So now, if we were to go back and go to our, let's see, seedcards.py, we can actually now create our first, or we could just create the insert statements here. So we can do DB client. So let's create a DB client here, up here. Let's see, let's call it client equals DB client. Okay, and the path is going to be studybuddy.db. Okay, now, and this is like testing our modularity for DB client. We're going to do client dot was it query insert into card, and then it's going to be label, description, category, like that, and then values. It's going to be question mark, question mark, question mark. Okay, and then params are going to be label, description, category, like that. I don't know what happened. I think my oh, there we go. My internet connection kind of. Okay, so let's kind of just bring that down here to make it look clear. So that replaces it. And then we're going to do that for every single item. And so that executes, in this case, well, we have 4 of them. So that'll do it for 4 times. And then what we want to do is we're going to have to close the connection when we're done with all of this. So close, oops, client. Okay. And that should be it. So if we ran this script again, okay, so now we've already loaded up all the data. So if we were to play our game again, we should actually have something. Python may not py. See, now we're getting stuff again because now cards table has something. Our seed cards.py script worked in terms of being able to being able to add cards into our card table.
I think so what happened is that we have inserted some sort of data into the database, and then we're able to get it from there. Is that
yeah. So let's say you were deploying this app to, like, I don't know, the cloud or something, right? Your DevOps person would be running this script first before deploying your entire app to the cloud, for example.
Okay.
Like this would be like a separate process where you would seed data into a database.
Okay, got it. Thanks.
Yeah. And that kind of just primes that database to have something. And then you deploy your app and then magically it works like this. Okay. So we're going to create something that will actually allow us to add cards in interactively or through the command line without having to have this seed script anymore. But the seed script is a good way to get us started, and it allows you to kind of see how we can actually leverage what we've written before to do other different things, right? So in this case, now we're fixed. Yay, fixed. This one is, what is this one? Presentation. Yes, and cooperative. when the process releases the CPU back to the OS or something like that. Yeah. See how smart the LLM is?
Mm-hmm.
What is cooperative multitasking? When the process releases the CPU back to the OS. And then the answer was a form of multitasking where processes are responsible for yielding back to the operating system. You got it right. Man, imagine having to like write code to check this to see if this is equivalent to this.
Mm-hmm.
Right? That's the reason why our LLM is so useful in that case. It's for these types of answers. Yeah. But yeah, now we have data. We're reading from the database. Nowhere in our study buddy, aside from our seed card script, right? Are we in a state where we need to look at data.json?
Mm-hmm.
Like that's it, right? In fact, I am so confident about this that I can just do this. Let's do make dir backup. Okay. Let's actually move data.json to backup. And let's also move seed cards.py to backup. And now we don't have it anymore. Okay. Everything we need is in our database. So if we were to run our game again, everything still works because our database is now our source of truth.
I see.
Yep.
Mm-hmm.
So does this make sense?
Yeah, that does.
Yeah. So we're making like we're connected to the database now, and all we needed was to just basically load our deck from the database, and that we transformed data loader to now interface with the DB client in this case. If we were to go back, right? Man, I wrote this in anticipation for like doing this, right? But I didn't end up doing it. But yeah, so now we have was it data loader? I'm just gonna leave it like this, data loader. Connecting with DB client. It also returns stuff back. This is our database. Okay. And then data loader passes a deck, generates a deck, right, to game. And this is a deck. Okay. So then now game also integrates with LLM client. And there we go. That's just the basic like, flow. Okay. So yeah. That's it for today. I think next time let's start creating like an interactive card inserting and deck assignment thing, or maybe like let's have our game be able to select various decks, like create different types of decks. But I think before we do that, let's actually just try to have some sort of management system that will actually insert deck information and card information. I'm thinking about making that a web app just for so that we can actually go over like what it means for like creating a Python like server and REST API and things like that.
Okay, that sounds nice actually.
Yeah. So like we get like the full thing, like our full cycle of development, right? There'll be another app, but it doesn't mean just because it's a different app doesn't mean you need like a different database. We're gonna actually leverage the Study Buddy database still. So you'll have, and this is what we most companies, right, when they create software, they usually use one like master database, like a main database, and all their apps kind of connect to it for like one ecosystem. So
does this mean that other people, like employees, could add to this or insert into this database and everyone could get data from it?
Yeah.
Oh, okay.
So then, nice. Yeah, it is, right? So, basically then this is like the start of something. Then you can add access control permissions, users. Users can be associated with certain decks, things like that. You can like go as far as you need to with this, but let's keep our scope small and just create like something that allows us to create new decks and new cards, assign cards to decks, and then like play the game with a specific deck,
Oh, Yeah, sounds good.
Yeah, cool.
Cool.
Yeah, let's
Thanks.
figure that out as we go along. Cool.
Mhm.
Thank you.
Thanks.
Thanks.
Bye.
Bye. So then I'm just gonna roll with the idea. I'm just gonna write like one big script called like maybe add card.py, admin add card.py. Let's just do that. Okay.
Mhm.
So the goal of this script is to just be able to add a card into our database, given some arguments. Okay. So
Mhm.
I'll start off by doing touch add or admin add card.py, and I'm just going to edit that. So the first thing I want is I want to utilize DB client. So I can do from DB client import DB client like that.
Mhm.
And then I can say, well, DB client is, or let's create something called client, and we'll say DB client, what is it? Study buddy dot DB is going to be the database we're going to create.
Mhm.
And then we're going to have maybe like a prompt, like what is the label of the card? What is what is the description, and what is the category of the card? Okay.
Mhm.
So we're going to say something like print what is, or let's just do this label. Okay. So we'll ask for a label, and then we do something like label equals input. I think that's how you do it in Python. Okay, let's test it. And then we can just
Yeah.
print label. Oh, that's how we do it? Okay.
Yep.
So, and then we'll also ask for description.
Actually, we could put the label in. Okay, so so input open parentheses,
Uh-huh.
and then you could type label within that.
Oh,
That.
okay, as a
And
prompt.
include the
Oh,
first print.
oh,
Yeah,
that's
I
even
think
more
it was.
easier. Okay.
Yeah. Mm.
Okay, thank you.
Yep.
Okay. And then category, right? So
Yeah.
those are like the three things that we need. Do we need like a space for like maybe? Let's do it.
Yeah.
Yeah. Okay. So let's test. Before we write into your database, let's just print it out. So I'm gonna do f string again, and I'm just gonna do label, description, and then category. Okay. And let's just test it. So by the way, in Tmux, if you want to get to the next pane, like I want to get to 4 right here, I can do you use your prefix key. My prefix key is Control S, so Control S N, and that'll get to the next one. Or you want to do it by number, Control S the number you want, so I'll do 3 here. So Control S 4, or you can do Control S N to get to the next pane. So.
Mhm.
Okay, so anyway, let's run it. So Python, what was it? Admin add card.py, and label will be something, other thing, category, and then there we go. We have our data, right? So far, so good. Now let's insert into the database. So we get rid of this. Add a new line here and do client.query. Okay. And then we can just do insert into card. And then our columns will be label, description, category, values, question mark, question mark, question mark. Okay. And then we do label, description, category as the parameters. And then we can say that is another line on its own to keep things small and tight. Okay. And then what we can do is select that from the database and see what we got from it. So how do we do that? I think we can just select one, right? The top one from the database ordered by descending, or we can select what was the last ID that happened to have been, or some, yeah, or we can select for the last ID, right? There's a feature in most database engines where you have a query to select the last ID, meaning that what was the last primary key that got inserted to the database? It'll return that value, and we can use that value to select specifically for that row in the table. Does that make sense?
Yep, that makes
Okay,
sense.
so let's find that out in SQLite. Select ID last inserted SQLite. Maybe it's possible, maybe not. So last insert row ID. So the function is called last insert row ID. So it's just going to be select last insert row ID, and that'll get us back the last row ID. Let's just see that. SQLite Python. Let's just see the Python version. How to retrieve the last inserted ID after inserting a row in SQLite. Oh my gosh. Okay. How to retrieve inserted ID after inserting row in SQLite using Python. Okay. Cursor.last row ID. That's all it is. Okay. Well, that means we need to actually extend our DB client class to give us that function. Because right now we're using our DB client. We only have query and close, right? Those are only two like API, right? Like that. Make sense?
Yep.
So we need to go back and then edit our DB client Python script, and then add that extra new API. So here. So we have query. Now let's just add a new one called def last. Let's call it last row ID, like that. Self. And then we'll just take our cursor. We'll create a cursor. Okay. And then what was it called? Forgot already. Cursor.last row ID. Okay. So we can just do return cursor.last row ID. Oh, right there. Okay.
Actually, would another way be select the top? Okay, so we could like rearrange the order from ascending to descending and select the top one from the table.
True. Yeah. I mean, that's a possible way to do it too. We can do both. Let's just try to do both for practice.
Okay.
Yeah, let's do both for practice. Okay, so now I have this new API. So if I were to go back to, let's say, admin add card. First, let's do it this way. Let's do last row ID. It's going to be client dot last row ID. So that'll be the last row ID. And then let's do client dot query. It's going to be, what is it? Select label description category from card where ID equals that, and we can say last row ID. So for once we have a parameter into our select. Okay, so that'll give us back how do I go back to the beginning? Okay, that'll give us back a iterator, right? Results iter. Okay, and then we can iterate through the collection. So for row in results iter, okay, we can say something like result row label. It's going to be row 0. Row description is going to be row 1. Then row category, it's going to be row 2. And then let's just print that out. F string again. Row label. Row description. And then row category. Like that. Okay, so let's do it this way first, and then let's do the other way later. So now we have this, and then when we test it, we should have, okay. Let's make a real card. What is paging? Paging needs to swap physical memory contents or contents in physical memory, right?
Mhm.
Contents in physical memory with contents from disk. Okay. The category operating systems. Let's do it like that. Okay. What happened? Weren't we supposed to print something? It looks like last row ID didn't give us anything. Let's see. Print last row ID. What was the last row? Last row ID. Okay. Was it because cursor is a different cursor, maybe? Let's see what this says here. I think it's because we made a new cursor object. That's why.
Mhm.
That's interesting. Okay. That's okay. Let's continue. Let's debug to verify that. I'm guessing that since we are, if we were to look at, let's say, cursor here, this cursor that we created versus the
Mhm.
cursor here, they're two different cursor instances. So they probably won't have the last row ID.
Actually, does execute create a new object called result? Is that the
No,
same?
that's the iterator that we return back anyway.
Okay.
Yeah. So, but remember, let's do the last row ID thing first, okay?
Okay.
So
Got
this
it.
doesn't work because I'm guessing that cursor this cursor here is because we created a new cursor object, which is
Mhm.
why we lost the ability to have we lost track of the last row ID in this case.
Okay.
Right? Yeah, this probably has information here. So I'm guessing if we were to do something like this, okay? Let's just print it out. Print last row ID from insert.
Mhm.
Let's do cursor.last row ID. Okay.
Mhm.
So that's the last row ID from cursor when we call the query to insert. Okay. And then we create a new cursor and we return that last row ID here down here when we call last row ID in our other script here. So this should be probably most likely, I'm guessing this is 0 or something. And then the one that we have in query is actually valid. So let's just check it out. So Python admin card at this test.
Mhm.
So last row ID from insert is 9.
Mhm.
Last row ID that we claim is none. Last row ID from insert is none. Does this make sense?
Yep.
Yeah. So we had to maintain that cursor object. Oops. So we had to maintain that. Okay. We had to maintain that cursor object. So maybe what we can do
Mhm.
is for now, I don't think it's any harm if we just have a self dot cursor here and do self dot connection dot cursor, and we can just reuse that cursor.
Mhm. Sounds like a good idea.
Yeah, I don't think that we need any different cursors or anything. Like I can't really think of a scenario where we need different cursors, to be honest with you. So yeah, like that. Okay. So
Mhm.
now that we have that clean, I'm confident that this will be fine now. So I will just get rid of that log, and then I'll go back here and I'll get rid of this log. And I think at this point it should work. So let's just try testing that again. And I'll just do test 2, test 2, test 2. And there we go. We printed it out right there.
Mhm.
So we were
Nice.
able, yeah, cool, huh? We're able to now at least retrieve the last inserted thing. Now, let's do it your way. Let's do the way you were saying. Like, wow, oops. Let's do it in a case where it's like, what happens if we can just tweak make another query to just select the top row, right? By rearranging, right? Or why don't we just write a query that does that? So, let's do it. What? How do we Control V? No. How do we block select? Windows, come on. Whatever. Okay. Is it Shift Control V? No. Sorry, there's like a Vim way to multi-select that works on Linux, but not on Windows. Yeah, okay, you know what? I'm going to, unfortunately, you know what? I'll just cut that. And then let's do this. So now that, cut all this. Okay, so now you have this idea where we can build a query to just select the top row by reversing it, right? So we can do something like this. So results iter again equals client.query select. So like
top one
label description, something like that, right?
Yeah.
Description category. I think top is a SQL. I think top is a SQL Server thing, but let's just refer. Let's just reference later, okay? But you have the right gist. From card, right? Order by ID, something like this, right? Descending. Yeah, that's what you were trying to do, right?
Yep.
Yeah. That may work too. Let's look at what SQLite is for top. So if we were to go here, SQLite limit 1. It's limit. Constrained rows, limit. Yeah, limit. So it's limit 1 here. Okay. So in SQL, and it's similar to MySQL actually. So we don't need top 1. What we want in this case is order by ID descending and then limit 1 like that. And then for row in results iter, let's just do row label is going to be row 0. What else do we have? Sorry. Row description. It's going to be row 1. Then row category. It's going to be row 2. Okay. And we'll just print f string. The row label. Then row description. Then row category. Okay. And let's test it out. It should be equivalent. So labels test 3, description 3, category 3, and there we go. We got the same effect.
Cool.
Yeah. So when might you want to do it this way versus the last inserted ID? For this case, there's only one person, there's only one process that accesses the database at once. So there's no concurrency in this case. So you can do something like this, right? You can do something like this, but this has no context to basically what you did previously, which was the insert, right? This is separate from your insert statement. Does this make sense?
Yep.
This is separate from the insert statement, no context insert state, right? So what ends up happening is that actually, if there was another process that was sharing the study buddy DB, if there was another thing that got inserted from another process, not your process, another process, like another script, between when you insert it to when you decide to select, it will actually select that new thing that was inserted from someone else. Does that make sense?
Yeah.
Yeah. Versus with the other way of doing it, the last row ID, notice how it uses the same cursor here of when you insert it. Right? That one has context to your query here. So if there was another insert that happened in between, right? If you use the
Mhm.
last row ID, it will actually only take into consideration your insert here.
Mhm.
Does this make sense?
Yeah, that makes sense.
Yeah. So actually, to tell you the truth, although this works too, I actually
Yeah.
think that the old way works better.
Okay, sounds
Uh,
good.
so basically, let's do it this way. That will be client dot last row ID.
Mhm.
Okay, like this. Okay. Let's
Mhm.
just, how do we how do we get rid of Scratch? I need to learn how to use this. Oh, there we go. Okay. Whatever. Results iter equals to client dot query select label description category from card where ID equals that. Then this will be last row ID.
Mhm.
Okay. And then for row in results iter, just all it is just practice. Row label is going to be row 0. Row description is going to be row 1. And then row category is going to be row 2. Okay. And then we say, let's create like a object. Okay. And then have it be dump in JSON. So we can just say from DB or from import, just for like display purposes, right? Like import JSON, and then we can just do something like this. Uh, object is going to be JSON.load s. Okay. Is it
Mhm.
load s or dump s? Dump s. Dumps. Wait, I'm trying to think. Actually, this will be string, JSON string, and then JSON.dump s, and then that'll be a dictionary. And I'm going to say it's going to be label is going to point to row label, and then description is going to point to row description, and then category is going to point to row category. I'm just doing this so that like it just looks easier to kind of, as a developer, it looks easier to debug later. Oh,
Mhm.
so there we go. And I just want to print the JSON string like that. Okay, as like a confirmation. Like here's your JSON delivered back. You can do whatever you want with your JSON, you know?
Mhm.
So, okay, so now let's test that again. Make it interactive. So test 4, description 4, category 4 hurricane. There we go. So now we outputted a JSON just to confirm.
Mhm.
If that makes sense. Okay.
Yeah. Yeah.
So I kind of want to do this in the loop until we hit Control C. Okay. So once we've connected to studybuddy.db, what we can do is we can just loop this, all of this right here. Oops. All of this here until basically Control C is hit to exit.
Sounds good.
Right.
Mhm.
Or should we actually, should we be safer?
Like have a flag?
Yeah. Like
Oh yeah,
quit.
yeah.
Yeah, let's do that. Let's do that. Let's just do that.
Mhm.
Yeah.
Mhm.
So let's do this. Let's just do this again equals false or true. Okay. And then while again. And then at the end, once we've inserted, we can do again equals input another one, and then yn like that.
Mhm.
And then, oops, why did I even? Like this, another one. Yes or no? Okay. And then what we can do is then if again dot lower equals y or no. Okay, we could say again equals false. Again input, sorry. Again input. And it will set the again flag to be false. Make sense?
Yep.
Yeah. So this is a loop listening on that flag. And then when once the user decides not to add any more cards, we can just close the connection to the database. So let's save that. Let's test again. Okay, so we say test 5, desk 5, cat 5. Again? Yes. Okay, label test 6, desk 6, category cat 6. Again? No. Done.
Nice.
All right, cool. So we have a way to add cards. Now, we've added a lot of junk into our database. Let's see if that's reflected in our game. So Python main.py, OSI layer 7, application layer. Okay. Paging. Oh, so we saw that one, right? Paging. What is paging? When we swap physical memory contents to disk. Let's just say that. Okay, well, the LLM says that's still kind of wrong. That's fine. Your answer, test 2, desk 2. Test 5. See, you've seen this, right? This is a junk that we added.
Yeah.
Yeah. So it is picking it up from the database. So that's good. So now the game is linked with the database properly, and that as we add cards from our management script that we created here, the next time you play Study Buddy, it'll pick all that up.
Okay.
Yeah. So that's okay, and so that is pretty much how we would do it this way. I'm going to leave it to you to create another script, maybe called admin edit card or something, where it asks for the label of the card you want to edit, and then you can update the description of the card or something like that.
Okay.
Yeah, maybe. Yeah, so for now, we just are into adding cards. And then maybe the next lesson will go into so I'll leave you to do all that, like the CRUD work, right? The update and delete card scripts. And then maybe in the next time we can talk about let's see, maybe let's talk about UI or something.
Yeah. Okay, sounds good.
Yep. Okay.
Okay, thanks.
Cool. Yep. All right. Thank you. Bye.
Thanks. Bye.
Okay. So last time we were messing around with adding new cards to our Study Buddy database. And since now I'm back on my desktop, I kind of want to show you what that actually looks like. We added a lot of like this test data. It's like test card, test description, blah, 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 blah. And I couldn't show you what that looked like in the database because at the time I didn't have, I didn't figure out how to do the DB inspection in SSH. Yeah, so this time I'm going to install DB browser and then see what's inside. I'll show you what's inside the database. Sounds good. Yeah, yep. So one thing I realized that this is actually a very good opportunity to, why is this disable inspection? Invalid? Hold on, let's just do something here. Source, is it? It's not here, it's VNV. Whoa, what happened? Where's my virtual machine?
Source.vnv.
Oh. Wait, you know what? I remember now. I turned off this new terminal thing because it was so obnoxious on the other computer. Oops. Yeah. Source.env bin. All right.
Activate,
There
yeah.
we go. I hate this new stuff. I'm sorry. I just hate this new stuff. We already did it, right? We were already in this BNB. It's weird. Whatever. I'm sure it works. I'm sure it works because if I did this. Oh, I need a pip install. You see, I've hopped around so many environments now that this one has grown stale. So I'm just gonna do pip install -r requirements.txt. So that's actually how we install a bunch of our packages from the requirements.txt file.
Okay.
Yeah, so we're in this type of situation where, let's say your colleague has introduced new dependencies and libraries into the project, and you do like a git pull, and you're like, what the heck? Now I'm getting this no module found request. The first thing I would look for is into your requirements.txt file, see if there's any new changes to it.
Okay.
Did someone add a new library? Blah, blah, blah. And if you see like a new library that you're not familiar with in this requirements.txt, it means that it's time to install.
Okay.
So if I do pip install -r is saying here is my requirements.txt file. It's just a path to it. Since it's in the same directory, I can just use /requirements.txt file, or I just leave it as it is like this.
Okay.
It works the same way.
Sounds
So if I do that, required file not found. Oh joy. Where is it? Requirements.txt. Is it just pip install? Requirements.txt. What the?
Shall we look it up?
Let's ask this guy. How do I install stuff found in requirements.txt in Python? This is it. Pip install -r right there.
Okay.
Oh.
How
wait.
sudo does that?
No, sudo would be for the root. You don't want that.
Okay.
Yeah.
Never mind.
So, let's do it. So, why is that? Pip install -r requirements.txt. There's something really wrong with this environment.
How deactivate and activate again, and then install it?
Okay.
Is this the correct?
Or maybe I don't even have pip.
Mm-hmm.
Right?
Let's figure it out.
Yeah. So let's deactivate. So source. How do I deactivate?
Oh, just delete everything. Deactivate.
Is this that?
Yeah.
Oh, okay. And then if I can just activate again.
Should we check if we have pip first?
Pip should already be in the virtual environment. I'm pretty sure on my non-virtual environment there's no pip.
Okay.
So there. So I'm gonna activate again and let's see if we have pip. So we don't have pip. So Python -m -m pip install -r requirements.txt. No module found pip. So we don't have pip.
Okay.
So how do we get pip in from this chicken egg? So do we just do sudo pacman sy python pip? So that's the arch way of installing stuff, right?
okay.
So we use pacman rather than apt. Yeah, so pacman. So sy means like just don't prompt too much for stuff. So yeah, it has it now. So I'll just say proceed. Yeah. Okay. So now let's do that. So we're gonna run pip install. That works.
Okay. Cool.
I think,
So for people.
hold on.
Okay.
This environment is externally managed to install packages system wide. What? So is it just regular pip now that we fixed ourselves? No. Python and pip externally managed.
if you wish to install a non-Arch package in Python, create a virtual environment, which you already did right here, right? Then use path to VMV Python. Which Python? Oh shit. We're using the wrong Python?
Python 3?
Yeah, I know, but it's supposed the Python is supposed to exist in a virtual environment.
Oh.
Yeah, that was supposed to point. So we're actually, that's the reason why, because we're using our global Python. So this is really broken right now. And that error made sense now, that the PyCharm. So we're really broken. All right. So I'm gonna deactivate. Okay, I'm deactivating. I'm gonna rf.env. Okay. Good. Now no more virtual environment, right? So let's just have this guy, this IDE, add a new interpreter. Let's just create a new virtual environment. So let's generate new virtual environment, right? With virtual end, okay? What's the Python interpreter based on? My window is, the UI is all messed up, but it's probably asking for 3.13. Okay, so it's gonna be based off of Python 3.13. Okay, we're gonna generate a new virtual environment. Okay. Inside this, we're gonna call it .env. Okay, and then okay. So now we're making a new virtual environment, but remember we don't have our requirements installed yet. Right, it's the fresh one. Okay, so if that is the case, okay, if I do which Python, there we go.
Okay.
All right. So now we're using our Python in our virtual environment. I have no idea what happened, honestly. But okay, now we do Python pip install -r requirements.txt, right? So we did that. Boom.
Cool.
So now we're good again. Okay, we're good. All right, great. So let's test it. Python main.py. Okay.
Hey, we're back on track.
We're back on track. Okay.
So wait, what happened? Like,
I think it's just been so long since I've been on my desktop doing this Python stuff that I think like over time everything just got like corrupted.
okay, got it.
Yeah. So if all else fails, blow away your virtual environment, create a new one, and then reinstall your dependencies. And to reinstall your dependencies, it's just this, right? Pip install -r requirements.txt. So I was right in the beginning. It's just I doubted myself because I was already corrupted. And that's an advice I would give to any new person. It's like, you know your fundamentals, right? And don't like, how should I say this? Like, you know your fundamentals, you know, like for example, I knew this is how you install Python packages, but I started doubting myself because things didn't work.
So how, if I was in a messed up state, how would I remove all that useless wrong files?
That's why I just blew away my .env folder.
Okay, so
It's all-
RMRF.
yeah, it's self-contained. That's the beauty of virtual environments,
Okay.
right? It makes it easy to just blow away, recover.
Okay, got it.
Right. So,
Thanks.
but yeah, don't doubt yourself so easily. Like if you know your basics, don't try to think that this is wrong,
Okay.
right? Try to investigate like what other things could be wrong. In this case, I got that error about like, oh, this is a system-wide thing, and I'm like, what the heck? I don't think so. I'm in a virtual environment. So I was like, okay, well, I keep saying Python. So which Python am I actually using? I'm technically supposed to be using the Python belonging to my virtual environment, but I actually wasn't.
Okay.
Because the which command, just for anybody who needs to know, which allows you to tell what is actually, where is this application coming from. So if I did which Python, we'll find that it's right here. Right, but consequently, if I'm not in my virtual environment and I just do which Python here, I get my USR bin Python.
Okay, cool.
Make sense? Okay, so now let's go back on topic. Let's actually see what's in our database.
Okay.
Right, so I actually don't have DB browser installed, and it's a good exercise in actually learning how to install Arch packages again. So I really like the Arch website because it allows us to search for what is the name of the specific package we need to install. We need to install that DB browser, right? So we look at here, we don't see anything. SQLite DB. No, not in there. So we should search DB browser SQLite Arch. Right there. It's called SQLite browser. Okay. So if it's the same one, we'll go to the website. It's the same one. Okay. So the Arch Linux website package browser has a list of all the packages available. You can just use pacman with. And for this one, we can just take the name here, and then we can just do sudo pacman-sy, paste that.
So if I use like Ubuntu, would it be sudo apt
Install.
install?
Yeah. If it's actually in the apt repository, right? With Arch, a lot of people are super active in curating packages, constantly updating them, and you're always gonna get the latest and greatest.
Okay.
And that's the reason why I like Arch Linux. So it's actually really easy to install now. So anyway, so now I have DB browser. I start that up, and then I can just open a database, right? In this case, I'm going to open up the StudyBuddy database. So if I open up StudyBuddy database and I decide to browse the data here, I see a bunch of that junk data that we have.
Yeah.
Right? So anyway, I want to keep that there because it is data. It's going to be fun, right? Like it'll be fun to have more data to mess around with. Okay, so I leave it to you to write the scripts for updating and deleting stuff, and then you can always check things for DB browser.
Okay.
Yeah, through DB browser just by refreshing your database with one of these tiny icons here. There's like a tiny icon right there. This one right here.
Okay.
Yeah.
The first one.
Yeah. So you can always like check that, and then you can even update and change things here. So for example, I can say for this one, I think I can just do like that, right? And I can just hit apply, and then internally it's going to do what we do with the Python script, where you just use an update query, right? So we just hit refresh, and it's right there.
Got it.
Okay. All right. Now the next step is I said last time we want to explore creating like a GUI of some sort, like maybe just like an HTML, JavaScript type of thing. But in order to do that, we need a server, right? We need a server application. And so this StudyBuddy right now is an application that is run interactively with a user in the command line, right? But what we also want to do is be able to have an API serving through HTTP, just like how Ollama does it, right?
Yeah.
Where we have an endpoint and a port exposed. Like StudyBuddy has its own port assigned, right?
Yeah.
And we have a TCP connection, and the web browser can create a TCP client connection to your StudyBuddy server, right? And then they can send HTTP requests, and your StudyBuddy can use all this logic that we've written here to just send back a result.
Okay.
Right? So how does that look like architecturally? Well, if we look at the architecture, basically what I'm trying to say is that take this to be the Chrome right now. Of course. Okay. Go.
Like the browser, or
Yeah. Let's just call it web browser. Okay.
okay.
Yeah. Okay, so let's take this as a web browser, and then we'll have like a user that uses a web browser here that interfaces with the web browser. Okay, so this entire thing so far is StudyBuddy. Okay. And I'm gonna draw something really big, okay? And then here's just Ollama. Small. Has the LLM. Right? So we know, and I know this is repetitive, but this is very good. We know that we have an LLM client that interfaces with Ollama through HTTP. Okay,
Yeah.
and that this is 11434, something like that. Port. Okay. We also have a game, right? That also interfaces with the LM client bidirectionally. So far, so good.
Yeah.
And then a game has a deck. A deck has a bunch of cards.
Yep.
Okay. And then the game also interfaces with a data loader, dload, which also, this one interfaces with a DB client, right? DBC. And DBC interfaces with a file system with a SQLite database.
Okay.
So far, so good.
Yeah.
Starting to look pretty complicated, right? Our architecture. Okay, so, and then we also have like on the side, like a bunch of scripts, you know, like our migrations, admin underscore scripts, you know, admin add card, admin update, whatever you're going to be doing,
Yeah.
stuff like that. This has nothing really to do with the app, right? This is just like, it's there for us to use, right? Notice how it doesn't connect to really much.
So it's like scripts to maintain.
Yeah, to
game?
maintain this game.
The
to-
operations?
Yeah, the operations as a DevOps, whatever you call it.
Okay,
And if
cool.
you deploy to this cloud, it would also be this too, you know, right? So we're gonna introduce a new thing. Okay, we're gonna introduce the Study Buddy API class. Okay.
Okay.
Now this API is gonna listen on a port. Let's just say it's gonna listen on port 8082. I'm just making up a number. Okay.
Okay.
Your web browser is going to connect to this API using port 8082, meaning it's going to look something like this. And then API is the endpoint, and then whatever function they want to run with some JSON as a body. Similar to how we did with Olama.
Yep.
Yeah. So now this API is going to just leverage all these other components here, like your LLM client, your game, your, you know, whatever. I haven't planned it so far yet, but it's basically like a different front end to everything, right? Similar to your main.py, right? We had a main.py before you had a user that played the game through main.py, which interfaced with the game. Right now, you can have another user that is actually interfacing with the entire Study Buddy through API web browser.
Okay.
So essentially, you can have two people playing on the same system at once. One through interactively, and one through API call.
Okay.
Yeah, but what the API allows us to do is that it'll allow us to have a UI here, like another project, Study Buddy UI. That has all the JavaScript and is just connecting to make API calls, so that the web browser can connect to this one. It's actually this one. This is actually the real flow.
So when you say API, does that mean like having buttons and text box to put stuff in?
Yep.
Okay, got it. Thanks.
Okay, so it's actually in the real in the real sense, the web browser is going to actually interface really with the Study Buddy UI, the front end part, and then the front end part is going to make API calls to this backend right here.
Okay.
This backend is at the same time also an interactive game. So we're going to kind of walk away from the interactive game now.
Okay.
Like this is now that is history. You can still play interactively, it's still there, but that's not going to be our goal for the next few sessions. The next few sessions we're going to think like a web developer now. Okay, we thought about like a game developer before, now let's think about web developer scenario. Okay. So I actually don't know how to like create really good APIs with Python, but I do know of a good library that we can just learn together.
Okay.
And it's called Flask. So let's learn as we go along. So Flask Python, right? So Flask allows us to easily start to create like APIs, listening over on HTTP. Okay, so
Wait, this is free, right?
this is open source and free.
Okay, good.
Yeah.
Thanks.
Yeah.
It's kind of
So
important.
yeah, of course. Yeah, I know you have a humble job. We all work. We have to pay the bills. So yeah. And actually, to be honest with you, I would never teach anyone anything that requires a lot of money to buy.
Okay.
So just letting you know. Okay. So yeah. So Flask has a lot of documentation, how to install it, what dependencies, whatever. I'm just interested in install Flask right here. Okay. The easiest way to do it is to have a virtual environment and then pip install Flask.
Okay.
Right. It's a dependency. It's a library, right, for Python. I encourage you to actually just like read a little bit of what it is, right? But I'm just gonna read it to everybody right now. Okay. So welcome to Flask's documentation. Flask is a lightweight WSGI web application framework. It is designed to make getting started quick and easy with the ability to scale up to complex application. So it's actually a full stack web development framework for Python. You could really create from end to end a UI all the way down to like database access and backends with Flask. It's like an all-in-one solution, but we're just gonna use the API parts of it.
Okay. Does it use like for the database? Does it use SQLite or something?
No. So you decide what database to use. Flask will provide you with the code and the APIs to access that database.
Okay, got it.
So yeah, it's of course it's going to internally use SQLite libraries if you want to use SQLite. It's also going to use MySQL libraries if you want to use MySQL, Postgres for Postgres. It's just abstracted away into like a simple Flask API.
Okay.
But underneath the hood, you're not concerned about exactly what libraries you use as long as it can access your database.
Sounds
Okay.
good.
Okay, so that's what Flask is. All right, but again, we're just going to use a very small portion of it, and then we'll just build from there. Okay, so the first thing that we want to include the Flask library, so it's pip install Flask, and so I'll do that here. Pip install Flask like that.
Okay.
We already in a virtual environment, so it's okay. Oopsie. There we go. Boom. Okay. I think we're supposed to I think proper practice is that we're supposed to update the requirements.txt, right?
Yeah.
So again, I need to look that up. So I'm going to look at here is Python update requirements.txt, right? So how to update requirements.txt? Well, it's just simply, well, thank you. This is why the internet kind of sucks now.
Too many paywalls.
Yeah. So here,
Okay.
then that's Reddit. Okay, that's weird. So what? It's just pip freeze output requirements.txt.
So like overwriting the current
Yeah.
requirements.txt file?
yeah.
Okay.
And we'll see it in action here. Let's just open it up and see it update in real time, okay? So we do pip freeze requirements.txt.
Oh wow.
Yeah.
Okay.
So now it has all the Flask stuff, right? So see, we see Flask 3.1.0, but we also pulled in all these things because Flask relies on these libraries too. So okay, so now we can get started flasking, right? So I'm gonna make a new class. I'm just gonna call it, or a Python file called api.py. Okay, so nice and clean. Okay, so first things first is like whenever you think about creating something new and complex, and especially with a library that you're not familiar with, again, always create a test script to learn how to use the library and then figure out how to bring in your own custom logic to it, right? So my goal for this is, since I am not familiar with Flask, can I just create a Flask server? So can I just wait, can I just do it like this? Yeah. Okay, so can I create a Flask server app that listens on import 8082. First of all, then after I can create that, well, I need to test it, right? So I need some sort of HTTP function endpoint. We call it an endpoint. You know, like a
Okay.
route to hit, right?
Yeah.
Can I create a route with a route handler? So that maybe something like curl or Bruno can hit to test to see if it's everything it can be connected. You know, so that's like those first two things I want, like a hello world kind of thing.
Yeah,
from
to
HTTP.
test that it's alive.
Yeah, yeah. Okay.
Okay.
So that tests Flask to like the basic patterns of Flask.
Okay.
So again, I'm not familiar. Okay. You know what? Let's actually just write the changes here and then close this. Okay. Now, let's go back to the internet and quick start. Okay. Well, let's do quick start. So this is how we actually create a minimum application that listens on some sort of port and has one route, which is the index route. Okay, so what does this type of thing mean here? So let me explain. So you have something called and I'm just actually, to tell you the truth before I begin writing this down, the reason why I seem so confident in explaining this part is because I've worked with many web frameworks in the past and they all have this same sort of pattern to it. So it's not like I know Flask, which is what I'm telling you, but this is standard. Okay. So so if I have something called app.route, like
And the
this.
slash thing is root, right?
Exactly. So basically what this means is that you're defining an endpoint that looks like this. Suppose your app is on port 8082. Okay? You're defining an endpoint like that.
Okay.
That's it, right? So then if I said app.route like that, that means I'm defining an endpoint that looks like this.
Got it.
So that means you have to go to here to invoke the route handler associated with some. So for this one, the example is saying a route handler at index, meaning that if someone input this URL in the browser, for example, then they would return some HTML called hello world.
Okay.
Okay, so that's like the pattern, right? So you can like organize your way that way. Okay, so yeah, let's just do from Flask import Flask app equals Flask name. Okay, so I'm gonna shift my window one over so that I can just like kind of switch back and forth like that. Oops, like that. So I can just do that. And then there we go. Okay, so now it would just be good for me to reference. So, all right, let's begin. I already forgot. So from Flask import Flask, from Flask import Flask, right? Next, app equals Flask Dunder name. So
What
app,
does the Dunder name mean?
we'll find out. Oops, we'll find out, right? Okay. Now, we imported a Flask class. An instance of this class will be our WSGI application. Okay. Next, we create an instance of this class right here.
Okay.
Okay, that's a constructor. The first argument is the name of the application's module or package. Dunder name is a convenient shortcut that's appropriate for most cases. So Dunder name is actually this file name without the .py. Why don't we try it out, right? So it's harmless right now. We're just creating instance of Flask, right?
Okay.
So we just do print name. Nothing's gonna happen. At least I hope. You know what? I'm just gonna comment this just in case. Okay? Then we can just do Python API.py main. It'll be the function.
Oh, okay.
Okay. So I guess it's the function. Alright.
Yeah, I need to do stuff like this more often.
Yeah. So I'm wondering, does it make sense to call this name? Can we just provide our own and just say API? I kind of want to do that. Yeah, just to be clear. So this is needed so that Flask knows where to look for resources such as templates and static files. Yeah, it's a convenient shortcut. It's just like a label. All right. So then we use the route decorator. So now we're here. So let's define a route, okay? I'm going to define my first route. I'm going to do @app.route, and I'm going to say hello. Let's define one. No. Let's do ping, okay? And then we have to define a route handler for this, like a function to run, like basically saying, given this route, run this function.
Okay.
Does this make sense so
Yeah.
far?
Yeah.
Okay, so I just want to do this. Def ping handler, okay, return pong.
Okay.
Remember, web browsers operate on text. You have to return some text or whatever, right? In this case, for an API, you usually want to return either XML or JSON. Nowadays, we do just JSON.
Okay.
So I can do something like this. A dictionary, right? So result dict. I can say this. Result pong. Right? And then I can just use JSON.dumps result dict to get the JSON string. I just return JSON.
Okay.
Right? So given this handler, so if I go localhost :8082/ping, if the server is running, it'll say, oh, /ping, oh, I'll run the ping handler. So it will run this function, do all this work, and then returns you back that string. You can return HTML too if you wanted to.
Sounds good.
And if you can have an HTML file, you can do the read file and then read it into text and send it back to the browser. That's really the basics of web development. Okay, that's just like you're just sending strings back and forth from your server. Okay, so we use the route decorator to tell Flask what URL should trigger our function. Okay, now the function returns the message we want to display in the user's browser. The default content type is HTML, so HTML in the string will be rendered by the browser. Okay, doesn't matter. We'll figure that one out later. Okay, so how do we start this Flask application?
Yeah.
Yeah, how do we run this? Obviously, it's not as simple. It doesn't seem to be as simple as Python API.py, right? Because nothing happens. Right? Nothing, because we just created this. We defined the function, and what now? Right?
Yeah.
Do you know what I'm trying to say?
Yeah.
If we run it, nothing happens. Well, nothing visibly happens, but we create an app. We define the handler, and then that's it. That's the script did its thing. It's done, right?
Yeah.
I mean, we could like have a while loop here that just spins like no other,
Yeah.
right?
Uh-huh.
But no, it doesn't work that way. We need to bind this script to a port. We need Flask. So, as it turns out, Flask is not only a library, okay? Flask is not only a library, but it is also a web server. Okay? Server. Again, now we have to correct ourselves. And it's not really this that connects to. It's actually this that it connects to, and Flask knows to touch this. Okay, so now it's 8082 here. Does this make sense now?
Yeah, that makes sense.
So what we want to create is this here, and then have Flask just connect to us. And then your UI or whatever will connect to the Flask server. Flask server, we don't need to touch unless we're Flask team developing it. We just need to run it. It is already a binary, or not binary, but it's like a program you can run already.
So within the Flask library, are there like other like things like for sockets and so it can access servers through the sockets and stuff, right?
You mean does Flask implement stuff like that?
Yeah.
Yeah, Flask has all that code in there already.
Okay, got it.
Okay, so you don't have to write sockets code from scratch. Is that what you're saying?
Yeah.
Yeah,
That's
You don't. Yeah, you don't have to do that from scratch.
Okay.
Yeah, I know at school you had to do everything from scratch, right? But Flask implements all that. It's just all high level at this point.
Okay, got it.
Yeah,
Thanks.
yeah. So we run it by doing Flask command dash dash app hello run. Okay, so to run. Okay, so save it as hello.py or something similar. So this is hello.py, okay? Make sure not to call your application flask.py because this will conflict with Flask itself. So as you see, Flask is a framework. Frameworks hard-code a lot of stuff in their logic, right?
Yeah.
To run the application, use the Flask command or python-m Flask. You need to tell Flask where your application is with the dash dash app option.
Okay.
So since it's API.py for us, it's going to be flask dash dash app API, and then run is the thing that we want it to do.
Okay.
Okay, so let's just have it run on its default port. Oh, right here. Yeah, so we can have it run on this host, bind to everything. Let's do that with a custom port.
Okay.
Okay, so let's do it. So we could do flask dash dash app API run, right?
Yeah.
And I think we did dash dash host right here. What was it again? Equals. Oh, after the run. Port 8082. Right? And then let's do what else do we need to do? Is this okay? That's it. So let's see what happens. So we did this. Okay. It says name or service not known. Is it because of the port throwing it off? Yes, the port is throwing it off. So what do we do for port? So it did work, but it chose 5000, right? So do I just do port equals 8082? Indeed it is.
Oh, okay.
Yeah.
Nice.
So this is the command, right? Flask dash dash app API run dash dash host 0000 port whatever. Okay.
Okay. And why are there two ports here? Like.
No, so that's what I'm saying. Like, so you need to know the concept of 0000.
Okay.
0000 means on all IP addresses that's associated with this local computer. So there's two, right? There's a local host, and then there's the one that I have connected to Ethernet right here.
Okay.
Okay, if I did not specify that, let's just say I didn't specify that, it'll choose the most convenient one as the first one, which is this one, 127.
Would that be an issue?
Yes, it means that any other computer outside of this computer cannot reach the server.
Okay.
Right? So, like, for example, let's just say this. Actually, let me show it to you this way first. Okay? If I were to click here, and let's just test it now, and do slash, what do we saw? We would call it ping, right? I got pong.
Okay.
Okay?
Yeah.
Now, let's do it a different way. Let's say we didn't want to bind to one local host. Okay, we want to bind it to 192.168.1.108. Okay, if we did that, now it only runs on this interface here. Okay, but it's still our local computer. We know this is our local computer,
Yeah.
right? We know we're running this server on this computer. So what happens if we do this? Unable to connect
Oh.
because it did not bind. Remember, what is actually needed to create a socket connection? You need two things. You need the IP address and you need the port. We have provided the IP address, but it's not 127.0.0.1 in this case. It is 192.168.1.108, which is our internal IP, right?
Yeah.
Then we do slash ping again.
Okay.
Does this make sense?
Yeah.
So, in order to get around this, like where it's like, oh, which one do I run on? It's like, right? You want to expose it so that not only your local computer can access the server, but you want, like, let's say my laptop. I want my laptop to use Study Buddy too, but this is I want it to touch this server, right? So we just usually do this to bind all.
Okay.
Bind all the IPs that you have on this system. There's only 2 on this system, right?
Yeah.
And I think if I were to do this IPA, that will actually show you all of them that you have on your system. So in this case, right now, I only have this one, my loopback, and then it looks like I have this one right here. Okay, so this one's they're not connected right now. Okay, so now, I mean, spoiler alert, like we have something,
Yeah.
right? So this, so by default, every single like HTTP request is going to result in it being interpreted as HTML.
Okay.
So if you kind of just look at inspect here and look at the network, right? Let's just reload the page. Notice how it's coming back as the /ping comes back as content type text HTML. And then if you look at the response, right, it's JSON, but it's being rendered as this. Okay, so actually usually APIs, we don't really give back HTML. We give back some sort of other plain text format,
Like XML
or JSON.
JSON.
So we want to actually configure our endpoint to be JSON. Okay, so let's override that. So if we do this, headers, okay. So we have a tuple, I think. So a return value from a view function. No, that's not what we want. Oh, JSON. Right, APIs with JSON. So what do? We just return the object.
Okay.
We don't need to return a string. We return the object as is. And that'll automatically be interpreted as JSON. So we don't need a dump S, we just return the dict. Right, so we did this, okay?
Yeah.
And then we started our server, okay? And then we hit our API again. Let's hit our API again and see what happens. Boom.
Cool.
So if we look at this endpoint here,
Yeah.
this endpoint call, content type is now application JSON.
Okay.
Okay, so you can kind of see what you can do with this, right? So I'm going to close it out by writing a quick endpoint to deliver you back a list of all the cards.
Okay.
Okay, so what do we need here? Well, we need DB client,
Yeah.
right? So we can say import DB from DB client, import DB client. Okay, so let's define a new route. Let's do app.route cards. Let's deliver back all the cards that we have. Okay,
So once we hit /card, the endpoint of /cards, we will see the JSON text.
of all the cards that we have in our database.
So
but we have to build that. We have to build that.
Okay.
Right. So I'll show you right now.
Okay,
So
got it.
let's have a cards handler. Okay. I just call it handler just because it kind of describes what it's trying to do. Okay. People would normally do this to API cards handler. Right. So. So now what do? Well, let's make DB client a DB client instance. Okay. So we could do. Let's actually open it up here. Okay. StudyBuddy.db. Okay. So then now we're opened, right?
Yeah.
So do client dot query. Okay. Let's do select label description category from card, right?
Yeah.
And then put no parameters, and we get back what? An iterator, right? So this is what I mean. Iterators are good because you build your own list, right? So you go results iter. Okay. Now let's create an empty collection. Okay. So let's just say results like that.
Yeah.
For row in results iter. So we're gonna go through the iterator.
Yeah.
And then we're going to do results.append. We're going to make an object. Okay, what's this object going to contain? It's going to contain a label. So that's going to be row 0 because that's a tuple. Description. Okay, that's going to be row 1. And then it's going to be category. It's going to be row 2. Right, so we're pushing to this array. Okay. Now, if you think about it, arrays are also valid. They are also valid JSON.
Oh yeah.
Yeah. So if we do return results, in this case,
So what we're doing is we're having an array of called results, and we're iterating through the results iterer to get the row and appending that to the results array
Yeah.
and returning results.
yeah, we're creating our own object though. Just keep that in mind.
Oh, okay.
Yeah.
Object. It's an
Yeah.
object. Got it.
But
Okay.
then we're pushing that into the results array.
Okay.
Okay, so now we have this simple API call,
Mhm.
right? So I don't know where this came from, but okay, so we have to restart our server. Let's see. No module name DB client. Why is that? From DB client.
Is that the class?
Why is that? Dismiss this first of all. Why is that? So from DB client, right here, import DB client. Get rid of this first. Oh, is it because of the CLI? Or import module name. Yeah, so I think it's because this thing here is importing from another place most likely.
Oh.
So how do we do this? Let's look it up. It's probably at a different directory. That thing, you know, it's probably. So let's look at import custom. Let's just find a place. Let's do.
So are you like what's happening? Is it on the wrong directory or a different directory?
No, I think the Flask script is in a different place, right? So then it tries to look for DB client, it can't find it because this API .py is being run in a different place. In Flask, it's probably running here. Site packages Flask CLI.py. This is a real script that runs when you run Flask.
Okay.
The CLI.py. Right, it's a big one.
Yeah.
So I kind of want to understand, like, okay, if we had something custom, what do we do?
Okay.
Right. So
Sounds good.
yeah. So maybe I had the wrong assumptions. I don't know. So that's the reason why I'm going to ask the internet again. Right. Import library in Flask. Right. So proper way to import modules and run Flask app. Okay. So from source package import blah. Right. So he's having this issue too. See, no module name blah. Okay. So what did they say? Create an init.py in your source directory. In the init.py, import package 1 and package 2 should be like this.
Okay.
Okay. So what we need to do is I guess we already have our init.py here. So do we just import the entire module? Let's see. Like that. And then this will just be DB client like that. Maybe, I don't know. See, still can't find it. So my feeling is that actually what's going on is that this init.py is we should put our DB client in a subdirectory and put the init.py there.
Okay.
Maybe. Let's see. Hold on, let's keep reading.
Should we find another source?
Yeah.
This one has 0 upvotes. Maybe another one will help.
So whatever file starts the app, it has access to everything besides it and under it, making everything accessible to that scope. Python doesn't directly support what you want to achieve. Optionally, you can use sysappend to achieve your goal, but usually restructuring your app makes more sense.
Okay.
Okay, so install your module. Okay, So we had to restructure our app.
Okay.
So basically we had to move files around and clean up a little bit. Let's do it. Let's just do the DB client because we only need DB client right now. Okay, sure. Fair. The rest of our app is gonna be pretty broken. Yeah, because we're importing DB client elsewhere, but we don't need those things right now. We just need our API.py, right? So I'm going to then create a new folder. Let's just see what happens, right? DB client, okay, and then just have an init.py in there. This is what they say, you know. Okay, and then let's just move it here. Don't want to search for references. Just refactor. Boom, in there. Okay, import DB client. So now it's can't find it anymore. So I really messed something up. So what do I do? So now cannot find. Oh, is it just dot what? Just try it. Yeah, I don't know. Let's see. So let's just say this guy wants to import what? Module A, but I don't know what module A means. Something in converters. He wants to import something from converters. So converter has init.py, and then he has the classes there. And he wants to import from here. So does that mean I also have to then create another folder called API, and then a file init.py like this, and then put the API in there too, maybe. That looks okay. Failed to find. Oh, we need to go to where? How do I do this? API/API. There we go.
Is it working?
No. So let's see. While importing study buddy API.py, an import error was raised. How do I figure this out? So
Is there official documents?
yeah. So again, it's back to our how to import from the parent directory problem, right? And the solutions that everyone always says is to do this whole sys path appending. I'm sure you've seen that so many times, right?
Yeah, I've seen it.
But the other way is to do the init .py thing. But the problem is that I do that, but I don't know how deep we have to go. You know what I'm trying to say?
Yeah.
Yeah. So I don't know. Like, I do want to spend like 5 more minutes trying to figure this out, but I'm gonna try to clean myself up a little bit. So I'm not gonna save delete. I'm gonna straight up delete this one here, and let's just see what happens. So I have 2 folders, API and DB client. Okay, so this is new. So if I did this, now all of a sudden everything's all messed up, right? So we know that this DB client thing was, or this init.py up at the root is needed. Okay, so now we have one at the root, we have one at DB client, and we have one at init.api. So I'm wondering if this is enough, DB client, because it's this directory and then into this module. So maybe this, and then now it's going to be DB client .db client, and it looks
Oh,
good.
wow.
It started, you know what I mean? Like,
the red squiggly.
yeah. So
disappeared.
I'm just saying, like, this is me thinking, like,
Okay,
hey,
let's
this is
see.
okay. So now where are we at? So while importing StudyBuddy.api, okay, let's just cd into API and then just like do this. All right, so this is no module named DB client. So that's okay. Let's hack it up. Let's just do this. It sounds really bad, but let's just do import SQLite 3. And then I think we should spend the next session to really figure this out. Yeah. So I'm going to do this. Okay? I'm going to do that.
Oh.
Okay? And then I'm just going to do this just for the sake of showing you what's going on.
Yeah, for
right?
this session.
Yeah. So I really think that because it's the blinding the blind.
Yeah.
I think because we're both noobs.
It's not very protected right
Yeah.
now.
So let's just do that. Okay.
Okay, cool.
Just enough. You know what I'm trying to say?
Yeah.
Just enough. Okay. So we do cards. Internal server error. Fair enough. Okay.
Why is that?
So SQLite objects created in a thread can only be used in that same thread. So basically, this client has to be down here, I think, because a handler, this handler is running on a different thread, and the server has this is on a different thread. Remember, like the whole TCP thing. Every time the server has a different thread, and the connection comes in, that client connection gets a different thread to handle.
Okay.
So that client was not there.
Okay, got it.
So, so I'm gonna update that. So just basically put it on the same thing.
Yeah.
See what happens. Okay, let's try it again. Still. No such table cards. Okay. Welcome to web development. Try again.
Gotta iterate fast.
Yeah.
Why
What do we
is
get?
that?
No such table cards. Why?
No, the tables.
Oh,
hard.
you know why?
Oh, yeah. Different file
Yeah.
path.
Yeah, I think that's the reason why.
Let's see.
Yeah. Okay, let's do it again. Okay. There we go.
Oh, magical.
Yeah.
Okay.
So yeah. So in Firefox, it allows you to see this parsed version, right? Or you can see the raw data right like this.
Okay. Nice.
So that's all I wanted to show you. Let's figure out how to. This is so frustrating.
Yeah.
We have a limitation in our skill now. So we had to get this working before we actually proceed, but you know the gist of this now, right?
Yeah.
So then like your browser will be calling this API handler / cards, and then it'll run all this code and deliver you back whatever you want.
Okay. Cool.
Yeah. So yeah, this next time let's figure this out, then we can create UI that will render this beautifully.
Okay. Nice.
Yep. All right. Thanks. Bye.
Thanks.
All right. Okay, so welcome back to our Study Buddy stuff. Took a little break, but now we're trying to get back at it. I have my desktop computer again. So last time, you know how like we were super confused about how to like import things from different folders. How we like kind of just took the source code and the DB client, we just like copied and pasted here and like hoped it all worked well, and it ended up working, but then we were like, this is not going to scale if we were to make this project bigger, right? And so we took some time to kind of figure out like how do we actually import something from a different folder, especially like if given our API.py here is in our API folder, how do we actually import something like from a folder that's from the parent and is a child folder of that parent, right? So like as it turns out, there is a way, but it requires us that for every folder that we have, we need to put an init.py file. And that init.py file is an empty Python file, really. So you couldn't go in here; it's just empty. But basically, it tells like the Python interpreter like a hint. It gives it like a hint to say, hey, like from here, given this init.py file, it's like anything under here in that same level can be imported from elsewhere, kind of thing. It's like a hint, right? Yeah. And so how we actually now pull this off is like, let's say we have this API API.py file here, and we want to import something that's above inside another folder like DB client. See how they're at the same level here. We just need to do this dot db client import db client. Now what that actually means is that each dot needs to go up one level from the current file, like where it lives, right? From the current directory where that file lives. There we go. So if I have one dot here, basically what it's saying is that given API.py here in this API folder, one dot means to go up one, right? So now I'm at API. So the one dot is basically telling us that, okay, that's the current directory. So usually when we're importing things, let's say main.py here, you see how like we have this from game import game? Technically, I think this is still right. It just means to get the current, in this current directory, get the game module. So get the game module. Where's the game module? Game.py, and go in there and import game. Okay, so at the current directory, go to the game module, which is here, right? So I'm on main.py at the current directory, right? Get the game module, import game. Does that make sense?
Yeah, that makes sense.
Yeah. So now what this means is, given that there's two dots here, right? So it means that from the current directory, okay, go up one directory. Now go to DB client. So now I'm at DB client. Now go to the DB client module, which is on the DB client module here, and then go in there and import DB client.
Okay, got it.
Yeah, so it's not intuitive, but it once you kind of see what it's trying to do, it kind of, I would like to say it makes sense. It makes sense why it would be like that. It's just not obvious, right? So now we have like our code cleaned up here, where we can actually select a bunch of cards from our StudyBuddy-DB, right? And return back a JSON result. And from what we remember with the Flask API here, right, we just need to return back a dictionary. Okay, a dictionary for regular results, or a collection of dictionaries, which is going to be a list. And Flask automatically knows how to turn that into JSON. Okay, so here we get like a iterator back from selecting stuff from our database, and then we just like iterate through for every row, and then we just create a dictionary inside and append that to results, which is a list. So then we get like an array of JSON, right? And how we test that is we basically do the whole Flask run thing, right? Flask --app, where the app is relative to your current directory, which we're in the root right now of our project. So we're going to have to go to API/API.py, and we want to run with all network interfaces bounded, right, to the host, and then we listen on port 8082. So when we do that, we're now listening on all the IP addresses available on our computer. And if we were to just go to localhost, for example, here, control click into that, I think if we were to just do 127.808.2, it's not found because we don't have a route, like a default route, right? So we do have a cards route, and going into the cards route, it invokes this handler here that will just select everything from the database and construct this JSON here. Now, this JSON doesn't really truly look like this. It looks more like this, right? I'm going to zoom in so that you can see.
Yeah.
Yeah. So notice how it's like it's just like an array of a bunch of these types of objects, right?
Yep.
Yeah. So now at this point, we do have like data that we can use to make requests. Now let's actually try to make an HTML file with some JavaScript, right? So that we can actually render all this out given some sort of API call. Well, this is the API call, but we want to make a web page in this case, okay? So I'm going to go back to Flask, and then I'm going to search for, let's say, static content. Okay, I want to search how can I serve some static content. And what static content is basically any HTML, any CSS, any JavaScript, right? Any type of file that does not require code to generate or run as logic, if that makes sense.
Yep.
Yep. So like an image would be a static file, okay? Because obviously it's an image, and a CSS file is a static file because it's already pre-typed, pre-written. HTML because you've already typed it to and saved it as an HTML file. JavaScript is sort of different. In modern web development, we generate our JavaScript now by writing in another language and then compiling it into JavaScript. But ultimately, if you're not going to do any of that, you can just serve JavaScript as it is because that's what the browser ultimately understands in this case. Okay? So what we truly just want to do is we just want to be able to at least, can we get our Flask app right now? It's a server, right? Remember, we're no longer thinking about game. We're thinking about server. We're thinking about API now. Can we mount a route maybe at the root, right, to deliver back an HTML page? For example, can we do something like this? App.route like this, and then we want to get maybe home handler or index handler. Our index page, right? Can we actually make this work to give us back a web page? Because right now it's a 404 not found, right? If we were to go to our app again and go to our index route, it's a 404 error in this case. So we want to display something here, okay? For now, we can even just have something like this. Return HTML, right? Just plain old HTML, okay? We could just do that, okay? And if we were to restart the server again and then refresh our page, we actually have some HTML.
Cool.
Yeah, but that's not what we really want. We want to do it in like a file and have it automatically kind of work, right? So that's the reason why I'm interested in how we can actually just clean up a little bit. How we can actually clean up or serve a file, right? So how do we do that? So static content maybe is one of them, okay? So this is like probably from a tutorial, which is probably a little overkill of what we want. We want something very simple, so HTML pages, maybe. So maybe here, let's go through our quick start and let's see what we can get from here, okay? So our quick start here tells us that we're going to make a minimal application, and we did pretty much this just now. So if we go back to our code here, notice how they mounted at the index a route handler to handle it, and to just return regular HTML text. We did something similar here. Yeah, we did something similar here. So I want to know if there's like a more modular, consistent way to do that. So this is telling us how to set up and run the app, and this is how we can like run a debug mode to get these types of stack traces whenever there's like an error. Actually, it might be helpful to just run it like that. Why not? So let's do that. Let's restart our server and just add a debug flag, so in case if something goes wrong, we get the right error message. Okay. Let's see here. HTML escaping. That allows us to return formatted things, right? And this is basically telling us that, okay, we can actually use the variables passed here in this route as part of the content in our string. Okay, so for example, like Flask can have something like this, name, right? It could be just something else like X. Okay, so we could do hello world X in this case. I don't know if this works. I should just make a formatted string like this. Okay. Hello X. I think we have to escape it too, so escape for security reasons. Okay, and that is part of an API. Oh, the debugger will hot reload too. That's cool. So we don't have to keep quitting. Markup safe
Nice.
import. Yeah, you know what I mean?
Yeah.
Yeah. So that will automatically refresh everything. That's great. So let's copy that, print out escape. X will be what? Oh, so you have to pass this into. So given this will be passed in as the name argument, and then we can access it there. So same thing for here, X, and then there we go. And then let's try it out. So we can do root directory, ASDF, hello ASDF. You see that?
Yeah.
So that's the general gist. Hello. Okay. But that's still not what we want. It tells you about routing. Well, we can revisit all these later. But what I want is templates and like static things, right? So let's read this. Static files. Dynamic web applications also need static files. That's where the CSS and JavaScript files are coming from. Ideally, your web server is configured to serve them for you. But during development, Flask can do that as well. Just create a folder called static in your package or next to your module, and it will be available at the static directory on the application. So it will magically work. We can generate URLs for static files using a static endpoint name. So this is a helper that will build us the right URL to get to style.css, like build a link to it. Does that make sense?
Okay.
Yeah.
Yeah, that makes sense.
Yeah, so what we need is we need to create a static folder. They say that's how we're supposed to do it, near our module. Okay. And then we just need to create a file. I'm just gonna say maybe style.css. Let's create some CSS, okay? And let's make our fonts. Let's go to Google Fonts and just pick out some fonts. So fonts.google.com. Yeah.
So are we like structuring the data and adding some UI to it, or?
Yeah,
You
exactly.
mentioned CSS.
Yeah, so sorry, I should have been clear. So we already have our data here, right? So we already have our data here, which already has all the cards that we want in JSON. But that's not pretty, right? But that's like all raw data. We have this API, okay? What we're going to do is we're going to create a web page that calls this API through HTTP to get the JSON and then format it in JavaScript so it looks pretty.
Okay.
Yeah, we're going to create a web page that will do that, the UI that will do that.
I actually have tried using indent for JSON.dumps. Would that help?
No, yes, that helps, but again, we don't want JSON, right? We want a nice, pretty web page like this.
Oh yeah. Okay, never
Right?
mind.
Yeah, I know. I understand what you're trying to say. Like, we don't want to. I mean, we're not letting a user look at JSON. We're letting a user look at UI, right?
Okay, got it.
Yeah. So that's a good question. I mean, like for us programmers, we're fine looking at formatted JSON. That makes us happy, right? because we're so used to looking at things in the command line all day that like things like this, to us, this looks cool. This looks pretty, right? This is pretty for us already. But to your normal user that's going to be playing this game online, they're going to be like, what is this? They're going to be so confused. So
Okay.
so they want something
Yeah,
pretty.
I'm like, okay,
Yeah,
that makes sense.
yeah, totally. So let's pick like a font that looks better. So let's do Inter. Okay, so let's do Inter. Okay, let's do Inter. And I'm not gonna walk you through this like a lot. Just do get font, and what we can do. Actually, maybe I will. Yeah, let's go. So basically, you search for a font. Okay, what we can do is we can select what we want, right? So this shows you what it looks like in various forms. Okay, and then what we can do is what is layer 7, right? So that's what it looks like. Okay, so I think there's a way to kind of just start dumping this into our little cart here. So I think if we were to just, I think we were in right. So we just get font, and then this is directions on how to use it. We can't selectively get it in this case, or can we? Oh, we can't. We have to get everything. Okay, so we have to get all forms of it. That's okay. So we can get embed code here, and that's going to give us some CSS. Okay, that's going to give us some CSS that we can use. We want real CSS. Okay, so we can do import here, and we can just copy this code here. Okay, copy this code here, and then what we do is inside our CSS here, we can say font, or actually just all the way up here. So that's the import, right? We're going to import this font here from Google Fonts. Okay, at this point we have that's technically like a CSS. Think of it as like a CSS or a font file. Now we can specify for every thing under the HTML tag, or I'll even be more specific, body tag for HTML. We're going to use the font family as Inter and fall back to serif font. Okay, so this is basically their guidance on what you can you should style it as, but I'm just interested in making the font Inter. So this is usually the thing that you'll probably put. Okay, so I'll put that there. So now everything under our body tag, if we were to include the style.css file, is going to use the Inter font. And if somehow this fails to be imported, it'll fall back to serif.
Okay,
I can even have it fall back to Arial like this too. Right? So, but anyway. Okay, so that's our style.css. We've created that. Now, interesting, we can actually code our HTML by hand again by using the URL helper right here, URL4, right? So what we can do is let's hand make our HTML file here. So let's get rid of this thing here. It's confusing. It's not what we really want. Okay, and I'm going to make a new variable called page HTML, and I'm going to make it a multi-line string, and I'm just going to make basic HTML structure. Okay. Actually, I don't even know. Can we do F string like this? Oops. Oh, we can. Hallelujah. Okay. So we can actually just return page HTML like this. Okay.
Cool.
So title, we'll call it study buddy. Okay. And then the body, we'll just say hello or something. Or let's do this. Welcome to study buddy. Study buddy. And then we'll have a paragraph that tells us welcome to study buddy. Okay? Then we'll end our HTML. Now, what we want is to create a URL. So we'll go style sheet URL. Okay, that's a variable. It's going to be called URL4. And then what was the parameters? the static folder that we want, and then the file name that we want to make a link to. So static, and then file name, okay, and we want style.css. So this is going to generate a URL that will actually link back to here from the server. Okay. How do we import that? Where do we get this from? Oh, import flask.url4. Okay. So we did this. There. Now it's imported. So this, if we were to print that out, okay, that should give us something. Okay. So if we were to go back to our homepage just by this, nothing's going to happen. We'll just get the plain HTML, right? And if you look at the printout here, it says /static/style.css. Do you see that?
Mm-hmm.
That's what this generated here. Okay. Now
What other endpoint can we have besides static?
we can have anything we want actually, as long as we have the file available. So we can just do like something like data, right? And then stuff.text, whatever. And it will just specify data as to generate the URL for.
Okay, got it.
Yeah.
Thanks.
So, but I think the usual convention is static.
Sounds good.
Yeah. So now we have this URL generated, right? So again, the reason why you need to do this is because you need to generate a URL relative to the app. Okay, you can't give like a absolute URL, because if you deploy this to another server, the path is going to be different. So this will dynamically generate a path for you. So now that we have the path, we can actually modify our HTML to include it, the CSS. So we could link rel, okay, and we could say style sheet. This is to tell us what type it is of link it is. So we do type text CSS, and then I think it's called href or ref, yeah, but whatever. So it's going to be in this case style sheet URL, and that's how it'll work. So that's how we include the CSS in HTML. So this should end up being the URL that's generated here, okay? And I think if we were to refresh, should we see something? Oh, I think we need quotes here. So most likely we need quotes. Let's see. No, let's debug. Why wouldn't it work? Let's see, including style sheet HTML. Why am I all caps? How do I add CSS? Link rel style sheet href. Okay, so we don't need to type text.css. Right here, that's how you include it.
Sounds good.
Okay, so it's been a while since I've done web development, so So that's supposed to work. Do I not end it now? I don't think that matters either. I would be pretty shocked if it mattered. Yeah, it doesn't matter. So let's look at our network calls. Why can't it find the font? Well, it could find the style sheet here. Oh, 404 not found. So this is where it can't find this static style.css. So Flask lied to us. So why is that? I believe, and I actually don't know, but I have a hunch, right? I have a hunch that where it looks at is at the current directory of where you started your project. So we started our project in where? Here, right? Study Buddy, which is actually all the way up here, okay? So I have a feeling it's looking for static up here. So if I moved static up one directory, okay, I wonder what happens. That works.
Cool.
Yeah.
That was immediate.
Yeah, that's my hunch, right? That was my hunch in that, you know, this static folder is relative to where you start your app. Because if it says, because it was the root directory, it said root, right? It said, right here, where was it? Slash, right? That means root, project root directory, static style.css. Okay? So far, so good? Yeah. So now we have CSS. So cool. We're good with this. We know how to do stuff now. We know how to include static files. Now, let's see if we can include some JavaScript, right? So let's do some JavaScript here. Let's add it in our static folder. We could do app.js, okay? And just have a simple console.log function, hello world from JS, okay? So let's go back and actually generate our app.js. App.js URL is going to be URL for static. File name is going to be app.js. So that generates that. And how we include that in HTML is going to be script source is going to be quote, app.js URL. Okay. And that's going to be type equals text JavaScript. Okay. And then we can just end it like this. I don't know why for script tags you have to do it this way. It's weird. But so now it's going to generate this tag here in this HTML with app.js.url. So if we were to go back and go here. Okay, so now did it find app.js? Yes, 200. So, right, it's a 200 code. So it's go okay. What did it get back? It got back this thing, right? Now that's going to execute by your browser. So let's go to our console on our Firefox here, and it should say hello world from JS right there.
Actually, I have a question about that script tag. So in general, why is it called script? Are we supposed to like put some real script in between the two angle brackets?
That's a great question. So the reason why we don't put anything here, and that's why I say I don't know why we need to do it this way. In general, since we have the script source here, we're already including it from a different file. We're like importing it.
Okay.
Yeah, but usually, okay, that's a great question. Usually you can do it like this too. Script, your hunch is correct. You can do script text JavaScript like this. And then you can actually just write JavaScript inside here.
Oh, okay, cool.
You know what I'm trying to say? Like you can do that and then console log whatever. But I don't like to do that because I don't get my highlighting. Right,
okay, that makes sense.
Yeah. Yeah. So this allows you to develop JavaScript apps separately from like the presentation part of it. Okay. All good so far? Yeah. So now we have everything we need, except we still don't have a good way to deliver HTML. We have a good way to deliver JS. We have a good way to deliver CSS, but we have no good way to deliver HTML aside from hard coding all of this. So let's actually try to do that. Okay. So let's continue on with this little tutorial. And apparently there's something called a template. So I'm guessing that it's a file that the Flask framework is going to look at to deliver the HTML. So let's read on. Okay, so generating HTML from within Python is not fun. Yep, we just experienced that right here. You see this? That's not fun. And actually pretty cumbersome because you have to do the HTML escaping on your own to keep the application secure. Because of that, Flask configures the Jinja 2 template engine for you automatically. And this is actually a very popular engine to create templates. If you ever used Django or anything in the past, it's the same language. Writing templates in Flask is similar to writing templates in like Django or like Express templates and all that stuff, all the standard stuff. So yeah, So templates can be used to generate any type of text file. For web applications, you'll primarily be generating HTML pages. But you can also generate Markdown, plain text for emails, and anything else. For reference to HTML, CSS, and other web APIs, use the MDN Web Docs. To render a template, you can use the render template method. So we have to import render template. All you have to do is provide the name of the template and the variables you want to pass to the template engine as keyword arguments. Here's a simple example of how to render a template. So you just give the file name and then some replacement. It's like, I guess this is like in the template you can actually refer to this person variable. In this case.
So we could assign like arguments to like value keys of templates.
Yeah. So inside your template, you're probably referencing like a person or something like that, and it'll render as whatever the name you put here.
Okay.
Yeah, there's probably some variable. Just so you know, even though it's like a .html here, these templates aren't real HTML. Flask is gonna take this HTML and really turn it into real HTML. But the HTML here is like, kind of like a hint for you to know that it should be HTML format. If that makes sense.
Yeah, that makes sense. Thanks.
Yeah. Because if you look at it, this is not HTML, right? This does not look HTML. This is what we call the Jinja template language.
Okay.
Yeah. Okay. So apparently Flask will look for templates in the templates folder. So if your application has a module, this folder is next to that module. If it is a package, it's actually inside your package. So if we have, are we a module or are we a package? We're a package, right? I think, are we? I don't know. Let's just put it up at the root, see what happens. And then we'll just have like a simple template right here, and we'll deliver that back using this render template. How's that?
Sounds good.
Yeah. Okay, so let's just do that real quick. Let's just create a templates folder up at the root. Templates. Okay, and then let's just create like an index.html. Okay. Oops.
Curious. We have to name it template, right, for it to work, or?
Yes, it's a frame. Yeah, since it's a framework. Since we're why are you double typing? It's so weird. Okay, since this is a framework, there are rules and opinions about how you have to do things. So one of the rules of Flask, and if you ever worked with Django and all those other web frameworks, you have like a specific folder structure you have to kind of follow to make things work correctly. And that's the difference between a framework and a library and a programming language, right? A library is a code that you can use to integrate with your own code. A framework is something you build on top of. And this is a framework we're building on top of Flask. So then basically we're writing an extension of Flask using its own libraries and rules. Yeah, and approaches to things. So we'll just need to, let's just have something in our index.html just to see if we actually can see something. We'll just have that. Okay? We'll just display a title that says index.html. And yeah, so now let's forget about these two things for now. We'll figure out how to include them later. Let's forget about this page HTML for now, and instead use our render template API. So we had to import a new one called render template. Okay, and then here we can just deliver back render template. The template is going to be index.html.
This pillow is right for you. We've got your ideal support from soft down to firmer foam and anything in between.
Am I having
Choose
an ad
the shape
play?
that fits you best based on your sleeping position.
No, I don't
Sleep
hear
better
anything.
together. Shop now at sleepnumber.com.
I have a sleepnumber.com going in the background. I have no idea what that was. Literally, it was playing in the background. I think there's one of my tabs has a ad somewhere. Oh, this thing. Okay, it was this. Okay, I need to close that. Okay, so yeah, you probably didn't hear it, but I think the video will probably have that. It's okay.
Okay.
Sleepnumber.com. Okay. I'm not sure. I can't vouch if it's a good product, but yeah. Okay, so here you go. We render our first template by just using this render template index.html. We don't have any arguments to pass into it, so we just provided the file, the template, and this is going to cause Flask to look into this templates folder here for that specific file.
Sounds good.
Yep. So now the challenge is let's create some content, right? Let's do again back to where we were before. We're gonna say study buddy, okay? Study with me, okay? And just to make sure everything still works, boom, study buddy, study with me. But I want my font and I want my JavaScript back. So how do we do that? Let's continue. Okay. How do I end it back here? Oh, okay, here. Okay, so let's go back to static files, rendering templates. Okay, so we know that there's a specific way to put our HTML. That's great, but I want to do more things than that. So inside templates, you have access to the config, request, session, and gObjects, as well as the URL for and get flashed message functions. So we have this, we can use, these are all the things we can use inside these templates. Okay, but how do we do that? So basically what we want to do is whenever we want to execute some type of code, we have to use this type of thing here. I don't know what you call this. Brace percent thing. Okay, so then in between this is code. Okay?
Okay.
So what we can do here is we can actually now write our template, for example, this way, where we call URL for, and then we can just kind of just do this whole static and file name CSS thing. So, and I guess in our static folder, we want to find the file name, what do we call it? Style.css, and then we have that. But we want to include that, right? So how does that work? So is it just something like this? Link rel equals style sheet, and then href equals this. Let's see what happens. Does this work?
Why is there red squiggly? You under URL underscore 4.
Yeah, because that is a syntax error. Apparently I refresh it, it's a syntax error right here. It's a squiggly because it's wrong. Right? So it's wrong. We're using it incorrectly. So let's find an example in how to include CSS in our Jinja template. Okay? So let's look it up. Include CSS in Jinja template, Jinja 2 template. So use a style sheet in the Jinja 2 template. So this person is having the same issue as us. They want this in there. So it's just like this. So we have to have some quotes and it'll automatically be translated. Sure. So we need some of this stuff here. And I'm guessing since it's not a block, it might have to be the other, like double curly braces. Let's see what happens though. So yeah, we had to have a double curly brace instead, maybe. These are just like specific rules to Jinja. It's not real like programming. See, it works now.
That's cool.
Yeah, so if you want to inline some code, you have to precede it with these two things here, these two curly braces, and then it'll run the code in between there to generate. Okay, but I think if it's a block code, and you're familiar what block code means, right? Like if it's something that's going to cause like a for loop or an if condition or things like that, I think you have to run it like this. You have to write it like this.
Okay.
Yeah. So using that same logic, then I could do something like this. Script source is going to be URL for It's going to be, again, static file name, app.js, and then close that as a function call. And then it's going to be type, text JavaScript, and then that. So if we did this, then we're back to where we're at. So let's refresh, and we should see hello from JavaScript here. Hello world from JS.
Nice.
Right, so now we have some sort of a web app, right? So we don't need any of this anymore. And thanks to that debug flag, my goodness, everything just keeps refreshing automatically for us. So beautiful. Okay, so now how do we actually tie this in with our API here? Okay, well, here is where we need to add some JavaScript here. So we had to have a fetch API to fetch the data from the server. Okay, we had to make a GET request in JavaScript. How we do that is how we do that is basically you're going to do, let's just have a function, okay? A function, async function called fetch cards, okay? Now, in here, we're going to say, well, we're going to have something called fetch URL is going to be HTTP 127.0.0.1 port 8082 cards. Okay? Our method, and it's going to take an object as a second argument, which is going to be the options for the request. Okay? And it's going to be method. It's going to be get. Okay? Headers. It's going to be, well, I want to accept. It's going to be a dictionary. It's like the HTML headers you want, right? Or HTTP headers you want. So I'm going to say I want to get back application JSON. And I think that's it. It's as easy as that, right? So this is a GET request with cards, and I expect to get JSON back. So the thing with JavaScript is that it's like asynchronous, right? So this fetch is asynchronous. It's going to return us back a response object. But then inside that response object, we need to actually get the JSON associated with it. So first we have to do a const response like this. Await, right? So we had to await for this fetch to complete, and gets us back this response. Now we want to get back to JSON. So we could say JSON data like this. We could do await response.json. And finally we have the JSON data, and we can console log that out. Just see what happens. Okay, and then we could just call fetch cards here like that. Make sense?
Yep.
Yeah.
Makes sense.
Yeah. So this is actually internally a promise, but this whole async await thing makes it easier. It makes you think that it's synchronous. It reads top down rather than, I don't know if you've ever messed with promises in the past. You don't think top down that way. But this makes it read top down. It's just a syntactic sugar for promises. So let's hope this all works. So if I refresh, I do get an array back. You see this?
Yeah. I
Yeah.
see it.
So let's actually build that out. Let's build our HTML out, okay? So let's actually have like in our HTML, let's have a little container here, like a div that will contain all the cards. How's that?
Sounds good.
Yeah.
So is it like an array or a dictionary to hold everything?
Oh, I'm sorry. What do you mean?
Like when you say let's make a container.
Oh, yes. Okay. So right now we do have our JSON object, right? That's an array of our card objects that we decide to send back from our API here. See how it's hitting cards? It hits cards here, right? Yeah, so then it's a GET request, which is what we really wanted here. Makes a database query. We get back our array of results, and we just return that straight up as JSON object. So far, so good. Now your front end is going to wait for that request to happen to get an HTTP response back. But then in this HTTP response, you want to get back the JSON. So you have to get back the .json Like you call the .json to get back the JSON object. At this point, you have a list of card objects, okay? But that's kind of useless because you want to be able to kind of structure that data and display it as HTML.
Okay, got
Okay,
it.
so what we're going to do is when I say container is that I'm just creating an HTML element here that's going to hold all our HTML elements that we're going to generate, where each element is going to be representing the card.
Okay, sounds good.
Yeah, so it's,
Makes sense.
yeah, so this is going to be basically in here is going to be a bunch of other div elements that has all the card stuff like label, description, blah blah blah.
So
that make
we're making a div element for each card.
Yeah, and that's going to be contained by this card container.
Okay, got it.
Yeah.
Thanks.
Yeah, and why do we need this? We're going to have to retrieve this div object in JavaScript. So we need to get the document or the element by ID here. So we need to associate it with some ID. Yeah. So what we want to do here is now that we have our JSON data, we can say, well, let's get our container. Card container is going to be document. Actually, let's create a new function. Okay. Let's return the JSON data. And let's have a new function that says render cards. How's that?
Yeah.
That'll just take in the JSON data. Okay. Or how about this? Let's call it cards. Okay, cards. It's gonna be the list of the JSON. So then basically we say this const results equals fetch cards. Then we can say render cards with result. Right, so we return JSON data, we assign that to result, then we pass that back in to render cards. So first thing we want to get is a card DOM element, the card container. So we can do const card container, okay? And we want to do something like document.query selector. That's a new way to do it. CSS selector style ID is prefixed by pound, and we can just do a card container like this. Okay. Now let's actually then print that out. Let's see what we get. It's console.log card container. Okay. Now if we refreshed this, we get null. Why? Did we save this? We get null. Why? Uh-oh. Document.query selector card container. Okay, well, let's debug. Okay, so now we're using the dev tools for Firefox. I want to set a breakpoint here and a breakpoint here. Okay, so if I were to go here, okay, what does this hit? Okay, so document, okay, query selector, okay, card container. Our HTML has what right now? Well, let's just proceed. Let's go to the next one. Card container is null. Why is that? Let's just do it manually now. So if we were to go and look at our HTML here, we do have a card container. Okay. So can I do document dot query selector and can I do card container like that? I do get it. Okay. Okay. This is I'm doing this on purpose.
Okay.
Okay. No, I'm just kidding. I'm trying to save myself. No, this is a good lesson. This is a good lesson though. I know why, but
Okay.
yeah. Okay. So there's one thing you need to know about web development. Okay. Your code renders when it comes to the web, it renders from the top down. Okay, so far so good. Meaning pretend this link thing, when you put link rel whatever, actually what's going to happen is that the browser is going to go and fetch right away whatever's in this path. Okay, style.css. Once it downloads that, it's going to load everything here. It's going to apply all these rules or get ready and it's like cache. Okay, so far so good.
Yep.
After that, then it proceeds to go to loading the script. So at this point, okay, I fetched the CSS, I loaded up the CSS. So I'm ready. Next, go and fetch the JavaScript. Okay? Okay, do we have HTML yet at this point?
No. Yeah.
No. We haven't
Okay,
processed.
never mind.
Yeah, exactly. This is actually a common mistake, right? So at this point, I'm going to fetch the JavaScript. I fetch it, now I run it. Now I'm declaring these functions. Now I'm fetching the cards, and then I call render cards, and I'm trying to get the query document here, the element. But guess what? At this point, when it's running the JavaScript, this HTML hasn't been processed yet. The HTML text is there, but the objects associated with this HTML hasn't been built yet.
Oh, I see.
Right? So that's why it does not exist. Now, what we used to do back in the day was to say, okay, well, if we wanted to access the DOM elements, why don't we just execute JavaScript and all the DOM elements are loaded like this? Okay, that solves the problem, right? We load the CSS and then we process each of these HTML elements to make them objects, and then we run our JavaScript. By then, when we access our DOM, right, our document, we have everything we need. Does this make sense?
Yeah, that makes sense.
Yeah. So let's just see what happens, right? So if I were to do this, okay, now I'm back here, okay? Is it null? No, we have stuff now. So if I were to log it, I should get the same output as before, this div coming out. Because that's what we wanted to print out, right? Does this make sense? It's no longer null at this point. You're quiet, so maybe just something is not clear.
Oh wait, sorry. I used my computer, but like, what happened? Why do we see stuff now?
Like I said, because at this point, when we're executing it, since our JavaScript is at the end now, the DOM, the HTML elements have been processed as objects now.
Okay, got it.
Yeah, because just so you know, your browser isn't really reading all this and then like all of a sudden it knows things. It has to read the HTML and build out the objects associated with it. We call it the DOM.
Do we need the ankle bracket HTML, close the ankle bracket and all that stuff?
Yes. I mean, we can do that, but HTML is so like lax, you know that.
Oh, okay,
yeah,
got it.
Yeah, it's not a real. I mean, people are gonna hate me for this, but HTML is not a real programming language.
Okay.
Yeah.
I'm so used to HTML to know that it is HTML.
Yeah. Let's just do it so that it's less confusing. But do you understand? Like all this is processed in order.
Yeah, that makes sense. Thanks.
Yeah. Okay. So, this is actually, to tell you the truth, okay. It's okay, but not the right way to do it. What we want is we want to have listen for an event and then execute our code. Okay. So there is an event handler for this, like where we can actually include our JavaScript up here, for example, and then have something to wait for all this to be processed and then execute code, like scheduling. We want to schedule code. We want to schedule this code to run only when the DOM is ready. There is a way to do that. Okay, so let's look it up. Document on document loaded or something like that. DOM content loaded event. So how we use this is basically this: add event listener, DOM content loaded, and then we add our code inside this handler here. Okay. So it looks something like this. Document.add event listener. Okay. We want to listen for DOM content loaded event. Give a handler to it. I'll just say function for now, since I'm not sure you're familiar with arrow functions, but let's just do it this way. Okay. So now let's load up our page again. Let's add a semicolon. And notice how it still works. You see that? Because this is scheduling. Whenever this happens, this event happens, right? This is part of the life cycle of loading a web page, by the way. Like a lot of events get fired at various stages of when a web page loads. This is one of these events that get fired when the content of the web page is finally loaded. This gets fired, and any handlers associated will run these scheduled functions essentially. And since we registered one of them, this code actually runs.
Okay, so like it's triggered when the content is loading.
Yeah, this event fires when the content no, not loading but loaded, right?
Loaded.
Yeah. So that's why you see how this is executed first now. Isn't it? It's very early, right? This is executed very early. So now what ends up happening is that, okay, well, this JavaScript still runs top down, right? But then instead of executing the code right away, we're gonna add an event listener instead to say, hey, if once this DOM content loaded event has fired, I want you to run this code in here.
Okay. Got
Yeah,
it.
yeah. And when it gets to the very last part here, down here, and all this stuff has been processed into an object like a tree, the DOM content loaded is fired. Now, when that's fired, it triggers this function to run. Yeah. So that's the right way to do it. Okay? Okay, so whatever. Okay, now let's get back to actually rendering our cards. Okay, so now we have our card container. Basically, that's gonna be the parent tree. It's a tree, right? So this is gonna be the parent of all the nodes that represent the card. Okay, so let's iterate through the cards. So for card of cards, I don't know why JavaScript's like that. It's of, not in, for elements. Okay, we want to get what? The label, description, and category, right? So we can actually do this. Const label description. We're gonna destructure, basically unpack, okay, the card. Okay, we're unpacking this way. In JavaScript, we call it destructuring, but in your world, in this Python world, we call it unpacking, I think. Okay, so now so now how we that, and then let's create a element for associated with the card. So we can say const card HTML, or let's say card DOM element, because we're not really working in HTML anymore. We're working with objects in the DOM tree. We're gonna do document dot create element, and I think it takes in an argument. So we're just gonna create another div. Okay. Now we can actually start manipulating things inside. So we could say, oops, this should be category. Okay, so now we can say something like this. Card DOM element, okay. Oh, we can say label header, okay, label header. So let's do const label header is going to be document.create element, and let's actually make it a paragraph. No, let's actually make it H3, okay, a header 3. Label header, right, dot text content is going to be the label. So basically, this thing here, we want to give it a text inside. So we're going to create label DOM header, DOM element. We want to create a DOM element associated with the label. We want to make it an H3, okay? And then we want to give the content of that inside to be label. And then we want to basically append, okay, card DOM element dot append child to be the label DOM element. So basically card DOM element is going to contain one of these guys, okay? So now let's also create a description DOM element, and that's going to be a paragraph, okay?
So are we right now creating the element of div and paragraph, and then adding the text content into each of the elements and building from there?
Yeah, we're building it manually. So description.
Okay, got it.
Yeah. You kind of get the idea, right? Okay, so I'm just gonna do it like this for now, and I need to add the description. Okay. Append child. description. So now we have a nice small header that represents our label. Under that label, we're going to have a paragraph. Make sense so far?
Yep.
Okay, now let's add like a horizontal line. So this one's easy. I could just say append child. Okay, I could say document.create element HR. That's called a horizontal rule. Okay, so now this represents, and I skipped category. Let's just skip category for now, okay? So this represents a single card in HTML.
Yep.
Okay, but we want to add it to our card container so that it can render. So at the end, I do card container dot append child card DOM element, like that.
So we're building each card DOM element and putting into the container.
Yep.
Okay, got it.
And when you do this, it's going to trigger the browser to re-render. So we go here. Oops. Cards is not iterable. Why is that? Let's print that out. Oh, I didn't await. Await. So this should be an async function. Okay. Let's do that again. There we go. See, I get all this, right? But it says label header is not defined. Why is label header not defined? Label header. Oh, label DOM element. Okay, let's do it one more time. There we go.
Nice.
Okay, so it's a good start. Let's make it prettier next time. So this kind of makes sense, right?
Yeah, that makes sense.
Okay, so I want to before we leave, I want to tell you something here. This is not a good way to do it. Okay, this
What
is.
do you mean is not a good way?
Yeah, so in the real world and web development world, we don't build up these things manually. We use frameworks like React to actually output HTML, like DOM elements, if that makes sense. We're literally not doing this whole document.create element, append child thing in real life, in the real world. React will end up doing that for you. You just need to write React in a certain way, call its functions and blah, 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 and then it'll actually do all this internally for you. Because this is painful, actually, I think. I don't know about you, but this is painful to me.
Yeah.
Yeah. So. Okay?
Okay.
Okay. So, yeah, thanks. Bye.
Thanks. Bye.
Okay, cool. So we're back, and we're going to be doing more web development. Last time we just basically showed how you can take a JSON response from some sort of API endpoint and then render that detail out with HTML and JavaScript. Okay.
Okay.
Yeah. So in this case here, I think we should have, let me see if I can do this. Excalibur. I'm thinking like basic UI right now to, so like let's start working on the parts where we actually have like a card that displays like a label right here, right? And then basically we can say something like flip, right? To then turn this to, if we were to click on this, it'll turn into description. Okay. And then basically this will turn into, well, this will still be flip. And this will be toggleable, right? So label description by hitting flip. Okay. And maybe like a button here that goes forward and a button here that goes backwards. Like that. What do you think?
Sounds good.
Yeah. So let's just like have this like sort of like basic UI first for every single card. And then we'll wire up all these individual buttons to do whatever it needs to do. Okay? So let's take a look again at what we have here going on. So for sure, this will be like, no, sorry, it's been a while since I've done UI. Okay, let's do it the right way. Okay, so from here on out, red is just going to be like a kind of like a annotation, while black will be like the physical UI elements that we will see on a page. So this here is going to be the container of the entire like app, like the functional app. Okay, and then we can call this thing here the game container. So that'll be like a div. Okay, so div, and then let's just make an ID game container there. Now within this game container, we'll also probably have the card container. Okay, so here would be the card container. So that's the card container. So that's another div, right? And within the card container, we'll just have basically another div here that will show either the label or description. Okay. We'll also have something down here. Okay. That will be basically controls. Controls container. And then basically this one here, since it's visible, we'll just label it green. That'll be label. Maybe another div, okay? So label or description.
So right now, are we building many divs and then putting the data within it?
Yeah.
And then rendering it? Is
Yeah.
that what's happening?
Yeah, we just need to find a good structure, right? So so we'll have the label description here. I put it green. I annotated green so that we know that this is the visible part, right? And then these reds are just kind of like for structure, like skeleton that you can't see, just to keep things around. So these will be buttons. Okay, we'll have like a flip. Okay, and then this will be another button that is just, you know, previous, next. I don't know why I keep doing that. Okay, so these are buttons. So maybe we'll call this one button with the ID previous button. Previous card. Let's call it previous card. Okay, and then this one will probably be, you know, button next card. And this one will be button flip card. Flip card. So that'll be our basic UI. Okay. When it comes to JavaScript, we need to just update this, add functionality here to these things. So we have like basically 4 elements that we need JS for. But let's not worry about that yet. Let's worry about like rendering like the pages first. Okay? So I would say that these red things are actually static, right? Like meaning that we don't need code to generate them, so we could put them in our HTML page right away to give that structure. And then these green ones here are definitely going to be, this one here is going to be always updating dynamically, right? And then these things here will just perform the specific functions. Okay? Okay. So let's just get started by writing this HTML structure. Okay? So if I were to flip back to our code here, let's not focus on the JavaScript right now. Let's focus on this thing here. So we had a card container. Forget about that for now. Let's actually do a div with an ID game container. So that's our game container. And what I actually like to do is when I do wiring like this at a basic level, even like as like a new person getting into all this, I like to put CSS that kind of highlights the grid or like the outline of the container so that I know what I'm looking at. So I usually like come up with like a debugging CSS class so it gets styled as like, you know, a debugging thing. So I usually do something like div class debug outline like that. Okay. And then I would just update my style.css to have that. So if I say for any div with the class debug outline, I want to make sure that the border, okay, is 2 pixels solid red, right? So if we were to go here, is our stuff still running? I'm wondering if it still runs. Let's see. So if I were to refresh here, you'll see that it has a solid red outline. The reason why it looks like a big line is because there's no content in our div. Okay, so what we can do here is either we have 2 choices to kind of make this more visible. We can actually add content here, for example, content, just like some text, right? And what ends up happening is that if we were to refresh, it'll be outlined like this. Okay, so now we know that the game container is here, this outer div here. So then we can also add in, what was it? We have the card container and the controls container, right? So let's have the cards container. So class again, debug outline. And then we'll have the cards container. What does this say, card container? And then we'll just have card container here as like a label. And we can say this one's like a game container. And then we'll have a controls container. So controls container like this. And then we'll say controls container. So if we were to refresh again. Uh-oh. What happened? Oh, the JavaScript caught the card container right here. Let's edit that to not do anything. Because we named it card container and this was looking for card container. Because the JavaScript was still running in the background, if that makes sense. Yeah.
Yeah, that makes sense.
So here we go. So notice how it gets thicker and thicker as we go down, because the borders are starting to overlap each other. So we can do something like this just to make it more visual. So we can add some padding in each of the divs that we have, right? So let's say we had we had game container, card container, and controls container here. We can just add for each one of them a padding of like maybe 8 pixels. So we did a game container. So we have div game container, div card container, div controls container. So this is how you specify multiple elements. We'll just have padding, maybe 16 pixels. Okay, so we'll do this and refresh. There we go. Okay, and I would say like maybe add like margin between card and controls. Just so you know, the difference between padding and margin is this, where like for these 2 elements here, let's play around, okay? By adding padding, it's basically spacing between the outside of the boxes, okay? Padding is spacing inside the box. Does that make sense? Yeah. So if I wanted card container and controls container to be like just have some space in between each other, I would definitely have to add a margin Okay, so I can margin bottom, for example, for a card container to be maybe, let's just see the effects. If I did 20 pixels, you'll see it kind of does that. You see that? It changes.
Yeah, I see.
Yeah, visually. So I'll just say maybe give it 16 pixels for now, right? So then that, if I do it this way from the inspector, I know that this looks good. So I can go back to my code and specify card containers margin bottom to be 16 pixels in CSS. And that will finalize it, because this does not make the change permanent, because it's not modifying the CSS file. It's just modifying whatever is rendered on screen. If I would refresh again, see, it goes back to normal, right? So I had to make that permanent by actually modifying the, can you hear me? Can you hear me? Can you hear me?
Yes, I can hear you.
Oh,
Can you hear me?
Yeah, I can hear you. Can you hear me now?
Yes.
Okay, I knocked my headphones, so that's why. Anyway, so I was saying, it's like if you were to refresh this, since you didn't make changes to the CSS, you would not see the changes that you had here, because this only modifies whatever is rendered on screen on the browser, right? So we want this to be permanent, so we go back to our CSS here, and then we'll add another CSS rule for our card container, where we want we'll have margin bottom to be 16 pixels, for example. So now if we refresh the screen, it'll persist. Okay, so so this is in general like what we want, except I kind of want this to be centered now. Like I don't want it reaching all the way like here, right? So basically, let's play again. Instead of like randomly trying to like refresh, make a change, refresh, let's just see what we can do here, right? We can say maybe margin auto, right? For the game container. And then let's just say max width would be the 50% of the view width, like this. Okay, so margin auto means that it's going to try to attempt to center the div, right? And then max width would probably be the 50 VW, means basically 50% of the viewport's width. The viewport is any of this white stuff here in the document. Okay, so this area here is the viewport. To me, that looks too small. Maybe 75 of the viewport width is good. Okay, so 75% of the viewport width. So these two rules look good to me for the game container, so I'll do that. So here I'll say, well, for div game container, put that together, meaning that we want both this rule for ID of all divs, right? So we want, what was it, margin to be auto, and we want the width to be 75 VW. Okay. Oh, max width, sorry, max width. So we don't want it to be any bigger than that.
Actually, is it better to use like a percent or a pixel? Like, why is it better to use VW?
We could do percent too. That would just be by the parent container size in this case. We could use percent. We could use pixels too, but it's hard because if I had like a, let's say a 4K screen, right, it would look tiny, you know? Yeah, so we could do percent. Let's do percent then. We'll just do 75%. How's that? So instead of that, we could just say percent. I think it's probably easier to think that way too. Okay, so there we go. We have the basic structure. I personally think that we don't need these labels anymore. We kind of know now, right? So that's good enough. So let's get rid of this. So they'll just be flat lines now, right? Like that. Since this time we added padding, right? One thing to know is that since we added padding here, this is the reason why you see a space now, whereas before we would have seen like a flat line, because the padding is in consideration, if that makes sense.
Yeah.
Yeah, because if we didn't have any of the padding, for example, like this, it would look like that, right? So padding helps. Yeah. So okay, so far so good. Let's do this now. We want to be able to add some buttons. Okay, so to this controls container. And I'm just gonna be silly right now and add 3 buttons. So button type, button, I'll say this one will be, do I have emoji? No. I'll just say like that. It looks good on ligatures, but in reality, it's not gonna look like that in HTML.
Yeah, how do you get the jingle?
Huh? Oh, this is a ligature.
that.
This is a ligature for my font. This is a ligature.
Okay, got
It's one of those things, right? So that's what I'm saying. It looks like that, but it's not gonna be like that. So we'll fix it later, and we'll have to flip. So we want something like this, right? So kind of like that. Okay. You know what? I'm just spend some effort, and I'm gonna install a plugin, ULauncher. Actually, not that. Preferences, extensions, add an extension. Oops. Let's go to discovered extensions. Sort by GitHub stars, emoji. Let's add this extension here. Add extension. I want this one. Add the extension.
So, what the extension give us a set of emojis?
Yeah, I'll show you
What
this.
is it?
It's a cool ULauncher extension. Let me show you. Let me just show you. Okay. So, don't know why this is not working. Let's try it again. Unable to connect to GitHub. Please try again later or install the extension manually. To install extension, you need a working internet connection. What? Okay. Let's do that again. ULauncher, hello. Let's do ULauncher. Weird, my ULauncher is broken. Let's do this. How do we install stuff in Pacman? From Pacman. No, uninstall. Oh, there we go. Pacman RS. You remember the package? Okay, Pacman-RS package name. Okay, sure. So Pacman-RS ULauncher. Wait. Let's see. Where did I get ULauncher from? Sure. Okay. Do I have Flatpak? Let's see, Flatpak. Nope. Okay, so I do have Flatpak. So I'm gonna install the ULauncher Flatpak. So ULauncher Flatpak. Oh, come on. We don't have it? Do we have a Flatpak for it? No, but we have Arch install. Okay, let's just do that. Boom. Let's do it. The latest version, huh? Okay. ULauncher. Okay, cool. Okay, let's just Control C, reload. Let's just reload. Come on, ULauncher. Yay! Okay, great. Okay, so let's try this again. Let's try this emoji thing again. Maybe it might work this time. Where was it? Oh no. Discover. Sort by GitHub stars. I figure I might as well just do this to kind of just get my setup correct. There we go. There was just something wrong with my old install. It works now. Okay, so I'll save that. Okay, so I'll show you something pretty cool. So, okay, so basically I activate my uLauncher like this. You see the little kind of like pop up right here. I just need to type EM, and I can type left arrow, right? Hit enter, and I can just, oops, I can just paste that in there. Like that. And then same thing here. EM, right arrow. Okay, and I can just paste that in here. Okay, and then flip. I can just do EM refresh, maybe. EM reload. Yeah, let's do that. And then boom. There we go. So,
Cool.
yeah. So it's all text right now. We'll style it later. Too many windows open now. I'm just, oops, I shouldn't have done that. Reopen, close tab. What don't I need? I don't need this anymore. I don't need this anymore. Okay, so if I reload, there we go. Okay, why is there a little button here? I might have trailing code somewhere. Where? Oh, I need to end the tag. Okay, so if I refresh, there you go. Nice. It kind of looks okay. It looks ugly, but let's make the buttons more even. So let's make the buttons even.
Okay.
Yeah. So let's do this. In our style.css, let's do button for all buttons. Actually, let's do for any button inside the controls container. So this is how we do that, right? So go to controls container and then look for all buttons. Okay. We'll do width is going to be 100 pixels maybe, and let's see how that turns out. So like that, and we want height to be probably let's do 50. So it's like a rectangle in this case, so height is going to be 50 pixels. So we did that, we refresh, we'll have something like this. Not bad, right? So let's make the text size bigger. So font size will be large. Let's see what happens. Large is just like a relative number, right? Let's bump it up to X large in this case. And then we'll, that's ugly. Wait, yeah, that's ugly. Let's just do large. Okay. Yeah, let's just do
Wait,
large.
should we consider like people using like mobile devices? Wouldn't larger be better?
This
For,
is
like,
let's focus on, yeah, let's focus on web for now, and we'll test it on mobile later.
Okay.
Yeah, let's not, you know, let's focus on getting this working. Okay, so now this is our controls. Now here's the thing, it's not centered, right? And so I want this to be centered. So remember we had the whole margin auto thing. So we had something like margin auto max with maybe 50%, for example, right? So let's try that same effect here for this thing. So in this case, we're not looking for 50%. We're probably looking for maybe 25%, like that, maybe 30%. Okay. So max width would be 30%. That's like a quick and dirty way to center everything. Okay. So margin auto max width 30%. It might not scale correctly, but eh. So controls container. Let's go back up. Where do we have an override here? Yes, we don't. So let's add a div controls container rule specifically, and do again margin auto, and then max width We could solve all this with Flexbox too, but I don't want to go. I'm not ready for that yet here. So, there you go.
Actually, I have a question about Flexbox.
Uh-huh.
I have a question about Flexbox.
Sure.
So, if we use Flexbox, is that a library or like is it built into?
Oh yeah, it's just CSS. It's just
CSS.
yeah. So we could do something like this: display flex, right? And then we could say flex, or is it flex direction? Something like that. Could be row, right? So then, is it row or column? Yeah. But basically, we could start styling like this. I think flex direction would be column, like that. See, now it's automatic. You see how it's magic?
Like,
So, yeah.
yeah.
What's up?
I got it. Thanks.
Yeah, so we could even do that too, right? Like, so all of a sudden, for our controls container, we don't even need this anymore. We don't need max width anymore, right? But we do need the margin auto, okay? So let's just do it. Let's just do game container will be a flex box, right? With flex direction column, and we can get rid of all these max widths that we have sprinkled around. Like, yeah. Is that fine? Or is there something confusing?
Oh no! I said that's good.
Oh, okay, cool. Yeah, so here we want display to be flex, and then we can say flex direction. Could be column, right? And then for this one, we just get rid of that, and then everything will just work out just fine. There you go. Convenient, right? Okay.
Yeah, it is.
Yeah. So let's add some text in this label description thing here so that we know exactly what we're looking at. So I would say let's just give a sample thing here with maybe like a OSI layer 7 or something. And as it is right now, since we don't have it styled, it just looks like this, right? But I want to have it like be more like impactful. So again, I want to change the CSS here to be margin auto first of all. So now we have a controls container, but we also have a card container to control the alignment, right? So we just by doing that and refreshing, right, you'll have this. Okay. But I want the margin bottom. So this got overridden. You see how CSS is cascading, right? So basically the later rules will always trump the previous rule. So margin in this case is for bottom, top, left, right. Okay, and we had specified bottom for card container to be 16 pixels. The fact that we specify margin auto now for card container down here means that the margin overwrote this rule here.
Okay.
Right.
So what that means that we have to put the margin card container margin bottom below the controls container margin auto.
Let's see. So we did that, right? Let's see what happens. Indeed it is. So that's the answer. Yeah. So yeah. So let's also let's make the font bold. So fonts, what is it? Font weight would be bold. Let's oh, by the way, font weight can go up to like there's like a unit, it's like 100, 200, 300, whatever. 400 is like standard, 700 is bold. I think you can go super bold by like 900 or something like that. So let's see. Yeah, like this. Okay. Maybe too bold. Let's make it 800. Oops. Okay. Like that. And let's make the font bigger. So font size. Let's make it X large. Okay. So something impactful. Boom. Cool. So this is our like basic structure that we want. So we want to like cycle through cards, flip, you know, and just have the answer show right in front of us like this. Makes sense?
Yep, it does.
Yeah. So at this point, let's actually start to add some JavaScript, right? Some JavaScript. So we had a fetch call. We had this fetch call to get where is it here? This fetch call to make an API request, okay, to the cards endpoint here to get the list of cards, right? Then what ended up happening was where was it? We added we turned the result into an array of objects. Okay, so we use that array to then process through render cards to just add in HTML elements. So I would say now let's see what happens if we just keep this thing around in a global variable, for example, and then just render out the very first element of our page here to see what that looks like, and add the functionality to flip and go back and forth, if that makes sense.
Okay.
Yeah.
Yeah.
So let's have a global variable here. Not really global, but you know. So we'll have let. Okay, let collection or card collection. Card collection be empty for now. We'll initialize that to empty. Okay. And so here, card collection, when we make this API call, we get the JSON data, right? So we'll make the API, and then basically we can reassign card collection to be result. Simplify that, basically, card collection is this, okay? So now, what we can do is we can just have a function here. Let's just call a separate function called render card instead of render cards. Okay. Given the card, can we destructure the label, the description, and the category? Okay. Now what I want to do is I want to just simply get the card container, the card container element, and just set the label to be the label of the card, or the text of that element to be the label of the card. So I'll do something like document, say const card container is going to be document dot get element by, or we could say query selector in this case. Let's do query selector. So we just do something like card container like this. Get the ID card container dot text content is going to be label. Okay. So here we can just call render card with card collection as the pass in the first element basically of the card collection. It's JSON. Okay, so we can just even console log the first thing here, just so that you can see it, and it will just take this JSON, get the label and description and category key, and just do stuff with it. For now, we're just going to do stuff with the label. Okay, just by modifying the DOM element, we're going to trigger the browser to re-render everything, so we get that for free. So if we were to refresh it again, why isn't it working? Let's get rid of this. This is distracting. Okay, so why isn't it working? Let's look at this. Oh, it is working. It's just layer 7. Really? Oh yeah, because the deck is already randomized. Okay, it's already randomized. Let me get a new randomization. Let's see. Oh my gosh. This is what happens when you shuffle. Let's get the second card instead. Something other than layer 7. Because, there we go, layer 5. Okay?
Cool.
Yeah. So, it just so happens that layer 7 keeps ending up on the first card. That's the reason why. Because we only randomize it once, right, in our server. Okay, So, yeah, so that's the gist. So let's say we want to flip, right? So let's like kind of think about this flip thing. Basically, we want some sort of event handler when clicked, right? When this button is just clicked to perform some sort of action. And so when our app first loads, our JavaScript first loads, we want to basically find our button through the document.query selector again for that button and add an event handler on click to it. So that whenever we click on that button, some logic is performed. And that logic can be the act of just updating that DOM element, the card container DOM element, to contain the description in this case. So, so basically, in our DOM content loaded is when we can actually know. Remember, DOM content loaded is the event that gets fired when the entire DOM has loaded, right? And we had this function here to kind of set up our state of the world. So whenever DOM content is loaded, it means that our button is available. So that's our chance to basically hook up some sort of event handler to our button. So our buttons currently don't have any IDs associated with them, so it's kind of hard to actually pick that out through a query. So let's add some IDs. So we can add next. What did I call this again in the design?
Was it previous or?
Uh-oh. Uh-oh. How do I zoom out now? Fat fingered something. Whatever. Next card, previous card, something like that. So we can just say previous card. Sorry, I said next card, but previous card. Next card, and then flip card, right? Okay, so we can just kind of get those elements. So const previous button is going to be document.query selector. In this case, previous button, like that. And then we can hook something up here. Previous button dot add event listener. Okay, click, and then we can give it a function. Okay. For now, let's console log. Say previous button has been clicked. Okay.
So right now, are we adding event listeners to every button, and if we do press it, something happens?
Yes, exactly.
Okay.
Exactly. Okay. Okay, so this is the reason why you don't use PyCharm as like a web development tool. First of all, you don't get anything highlighted correctly, and the indentation is really weird because it tries to indent like Python, I think. So anyway, I'm gonna also add a flip button, event handler for flip button. And then flip button dot add event listener is going to just console log. Flip button has been clicked. I like to be happy about that. Const next button. It's going to be document.query selector next button. Next button dot add event listener. Click function console log again. I don't copy and paste because I just want the practice. Next button has been clicked. Also, just work on your typing, you know. Good opportunity. Okay, so now I have these buttons with event handlers hooked up. So whenever I click on them, they should emit some sort of console log. So in this case, if I were to refresh, if I were to Previous button is null. Why? Did I name it differently? Oh, previous card. What's a better name? Should we call it previous button or previous card? Because I assumed my mind went to button right away. You see that?
How about card?
Card? That makes more sense, huh? Yeah. I was so like into it being a button that I called it a button. It is a button, but it doesn't really describe what it really does. So I think, maybe card. Yes. Let's just stick with it. So if I click on previous, you'll see the log. And if I click on next, you'll see the log. If I click flip, you'll see the log. And when the log is the same each time, it kind of batches them up and gives you a count of how many happens straight. We can change that here, where you could say, group similar message. You can uncheck this, and now, wait. Hey, how come? Let me refresh. Hey. This works in Chrome. Oh, cool, multi-line. But how do we? But you kind of get the idea, right? Like you don't have to. This means
I get the idea.
Yeah, this means that there's 5 logs straight. So it's like that. Yeah. So if it's different, you see how it will do it all separately. Yeah. So we have button functionality now. That's cool, right? Let's just quickly, before we end the day, just simply add something that's meaningful to the split button and have it show the description. How's that? So
sounds good.
Yeah, so we're gonna go here. Let's just pretend and go current index of the deck is 2. Okay, and then let's change this to current index, and then current index. Okay, now for the flip, all we have to do is just again get the card container. So we just do const card container is going to be document.query selector card container. And what we want to do here is just set the text content to be card. Oh, we want to get the second card though. So what do we do here? We can just do current card. So const current card is going to be card collection at current index, for example, and then set the text content to current card dot description in this case. Okay. It's only going to work once. Our logic will flip the card and it'll just be a description going forward, but just for testing. So if we flip, we'll get this.
Nice.
Yeah, but it doesn't work anymore because our code is hard-coded to always do description, right? So what we can do is we can say, well, let's just have a dumb variable here. Flipped is false. Okay.
So this would be like a flag, right?
Yeah. So watch this. If flipped, if not flipped, we want it to render the description here, right? Else we'll render the label, and basically we want to update the flip like that. We want to just like toggle that flipping thing. So it works. Right, so make sense?
Wait, is that basically the flag we set it, and then when it is flipped?
Yeah, so if it's not flipped, it's going to change the card. It's going to assume that this is the first time you're flipping, so then it'll be description. If it's already flipped, then when you flip again, it's going to be label. It's the UI version of the code that we wrote before. If the card isn't flipped, that means the label is currently being displayed, right?
Yep.
Yeah. So then what do you want it to show? Like if the card is not flipped, that means the label is showing. But since this is the flip button being hit, what do we show instead now? The description. Right? Because you want to go from the label to the description. How about if the card is already flipped, meaning that's true? If that means the description is being displayed, right? So what do you want to go to? You want to go to the label now. You want to update with the label.
Like flip it back.
Yeah, flip it back. And you just need to make sure you just need to make sure you need to update this variable so that now it reflects the state of the world, right? Yeah, so basically if flip is false, it'll be true. If it's true, it'll be false. This is a dumb way to do it, but let's make it better next time. Let's make this better next time. But
sounds good.
But we have sort of some working UI now. Yeah. Okay?
Nice.
Yeah, so that's it for today. Yeah, we'll continue
Okay,
on.
thanks.
Yep, thanks. Bye.
Bye.